And one of the workflow and pipeline we are going to talk about for another 20-30 minutes. So let's start. So first, let us try to understand the kind of scale what we have at our organization here in Cloudera. We kind of close to 10,000 containers we create on a daily basis. And there are close to 50 plus different experiences or enterprise offerings what we work for. And we have a Docker registry container which hosts close to 80 TB of data, 80 TB of different container images and storage is what we maintain. So this is the premises what we have built on top of. We'll just quickly talk about how we have been doing it. So so once we started having this kind of workflow, we went ahead with having a managed cloud registry. We were using cloud-based registry management tool, and we were having single architecture images, what we have been building across all the experiences and across all the platforms and the stacks what we have. And we were looking into critical CV mitigations and scanning processes as well. There we will talk in detail about how we have built and how we have improved on top of this. But when we started, we were mostly looking into the most critical piece of CVs. And we were we were fixing all of them as part of our software delivery supply chain mechanism. Things were all going fine. Were all going good. And once we have a new kind of architecture developed by Apple Mac, we hit a roadblock. And this is the roadblock. Apple started releasing their laptops with M1, and we hit a roadblock in the kind of container pipeline, container generation pipeline which we had. And this is what we're going to talk about. We are not going to talk about what we have done, what we have talked about. That's why we are quick in that. This is the kind of whole process we'll talk about, what we have done to mitigate this process roadblock, and how we have achieved. And in addition to this, we found a better way of delivering containers and better way of having secure container delivery mechanism. And on a piece of cherry on top of this is we are able to support Graviton as well. We'll talk about what exactly is Graviton and why we are so excited about that. We'll get to know in some time. So I'll hand it over to Phil. He'll talk about more in detail about this.
Thank you. So hi, everyone. Phil here. So yeah, I think you might have already stalked us on LinkedIn, so we're not going to introduce ourselves. So yeah, as Vijay talked about, Apple Silicon came in. So this was good, right? So Apple Silicon was way powerful than the x86 architectures that we were having. And we started, and since in our Cloudera, we provide our developers with Macs. So obviously devs wanted the better machines. So everything was fine, but the Docker build command that you run on an x86 machine would create a single architecture image that is obviously runs only on x86. It won't run on your M1 Max back then, but now Apple provides an emulator, but back then it didn't, right? So this created a challenge that devs could not test the images that we were building for prod because our instances that we are running were on our on-prem data center that we are using to build our images that produces the images in x86. So devs were like, hey, we are building the images, we have the Docker file, we're building the images, but we can't test it. So we can't actually ship it to our customers saying, hey, we have run it. So this was like new team members came in, half of them have M1 Max, half of them have Intel Max. Somehow we got it through, but we had to find a solution to this. And since we were the developer productivity team, we were the ones who had to solve this problem. So yeah, devs. So there's the XKCD comic which says, "Hey, devs would say it works on my laptop," and we try it, and then because they would run it on an ARM64 V8 machine, and it won't. The build commands that they have in the Docker file won't run on prod, because, for example, you try installing a curl something using curl, and the endpoint would have the package name something that points to ARM64, and then when you try to use it on your prod on an x86 architecture, that won't work. So another problem that we have, since we said we have 50 plus data offerings that we provide, we have tons of build commands. So imagine we have make files, and each make file would have 5 to 10 Docker build commands, each of them dependent on each other. So asking devs to change their Docker build steps on each one of them, we didn't know the blast radius that would that would bring in, and how much disruption that would cause. And then the problem is infrastructure scaling. So with as Vijay talked about, we had a vendor managed registry, so that could not handle the multi-arch images. So how do you handle such scenarios where we have a lot more people wanting to use our products and a lot more customers wanting to use it on different machines, and how do we ship it to them? So yeah, first we'll talk about this challenge where devs could not test on Silicon Mac. So this is where we had Mobi Build Kit. So this was an experimental feature that was brought in I think Docker version 23, and then we also tried it on, and that was promising. So this enabled us to run a Docker image on multiple architectures. So first we would build the image for multiple architectures and then push it, and then we would be able to run it on multiple architectures. Then, so this was a deal breaker for us because we did not have any on-prem instances that was ARM64. So we would not be able to build our images. So multi-arch did provide us, the build kit provided us with the option to use emulators to build our ARM64 images. And this was one blessing in disguise that came in, right? So it's not just one more architecture. This is better for everyone. So this architecture provides better performance and less energy usage. So cost efficiency and energy efficiency, everything. And later, even AWS brought in their Graviton instances that was running ARM64 architectures and was better in every aspect. So yeah, this is about BuildX. So BuildX is the CLI plugin on Docker that enables you to build multi-arch images. So you could provide a number of architectures that are there to to build your images on. So these are some example of architectures like ARM64 v7. This is the legacy ARM64. Then a lot of other x86 and stuff like that. So yeah, so this BuildX would provide you three different ways to build your containers on multi-arch. So one is the Docker driver, which you just do Docker build. So that would just build a single arch image. Then is the Docker container driver. This enables you to build multi-arch images. Then there is a Kubernetes driver also, where you can connect your Kubernetes cluster, which has multiple nodes with multiple architectures, and that would enable you to build natively on these nodes and run Docker build commands natively on these nodes. So this is how we started off. Initially, we would create a context, and then since we wanted to ship only for, sorry, yeah, we wanted to ship only for these architectures. So we would create a builder, and then we would install the emulators and the binfmt binary for it, so that that could emulate the architecture for us. Though currently we are using something better. So Docker has provided support for containerd. So we went with this approach because initially the Docker image store that you have when you do a Docker image ls, that was unable to show the multi-arch containers that you had built. So now containerd provides you support where you can do a Docker buildx build and store your image locally without promoting it to a registry. So yeah, the second challenge that we had was having Docker, tons of Docker build commands, right? So how do we, not break stuff and do it in a frictionless way and also provide multi-auth support? So as it says, good DevOps is obviously making devs think that nothing changed in the backend, right? So this is what we did. We had a wrapper script that we wrote over our Docker CLI. So whenever if the devs wanted to build multi-arch images, they would just provide a flag in our build step, and we would map Docker build to use Docker buildx, and then provide, obviously with some tweaks, and we set the platforms that you use. And then, yeah, so we had some of our product teams who were using some of the images that did not support the multi-arch. So with BuildX, what it does is it provides manifest attestation by default. So we'd use this flag provenance false to to disable the manifest attestation. So this would, even though it's a multi-arch image, you would be able to run it on a Docker client below version 23. So yeah, I know this picture is like really small, but yeah, I'll just try to run through what is here. So this is how we integrated. So this section was what we first had when we were using just the plain vanilla Docker build. And this is where we added the multi-auth support. So we would check if people wanted to use multi-arch, and then we would use the wrapper. So this is where the wrapper kicks in. And then if all the build stages are successful, then we would check if the image is multi-arch or not and use different promotion mechanisms. So earlier we were using Docker push. We found out that was really slow, and we found there's an open source tool produced by Red Hat that is Scopio. So we use Scopio copy to promote our images from, so even if it's a one that you built using Docker build, we would promote it using Scopio copy. And then we had different ways of building multi-arch images. So all those ways we would ship it using Scopio. And then we would generate the manifest, and then uh, get the manifest details, and then yeah, just ship it. So that's pretty much a rough, super high level bird eye view of our build system. Then, so as we said, we had thousands of build commands. Different teams would have different ways of building stuff and different requirements of how they would want to build their images. So, and also, as we said, we have multiple data offerings. So we would have multiple images as part of one offering. So we would not want to ship images until we know that all the image builds went fine. So for that, we had multiple ways you can build image. This is the default. You could just build your Docker build, and then we would generate OCI tarballs, and then we would push it to our Docker registry. Then this is intermediate promotion. So this is the use case where one Docker image would be dependent on a previous built Docker image. So we can't really use OCI images for that. So we would push it to an intermediate namespace in our registry, and then use that image for the next image that is going to be built. Then this is one where images cannot use emulators, and emulators won't work well for native binaries. So this is where we had this option to split the image builds. And then, so we would build the images differently on x86 and on ARM. And then we would merge the manifest. We'll create a manifest list that would point out to each of these images. So finally, we are at the infra part where we want to, because these are so many images that just came in, how do we scale it? So we moved to an open source registry solution that is Harbor. This is a CNCF graduated project that we used in. So initially we started off with having it on-prem and then the backend on S3, but we had too much S3 backend costs, and we were having some issues with what if our on-prem nodes go down and the registry would become unavailable. So then we moved to a fully cloud native solution where we moved to AWS. So maybe a couple of meetups back, someone in Cloudera talked about EFS and EKS. So yeah, we were also doing it. So we used EKS with EFS backend, and then we took our Harbor database instance out, into RDS so that we would be even more resilient. And we have again we using S3 backend, but still it was in one AWS region, the costs were less. So this gave us the flexibility of using whichever instance size that we want, and then we would scale up and down based on how our teams are using it. And then we split it on multiple availability zones, so that where even if one AWS zone goes down, we would still have a registry up and running without affecting our users. Then yeah, again, if it's in cloud, it's not our problem, right? It's someone else's problem. So yeah. So yeah, this is again, so we started with, as we talked about, we started with Apple Silicon, and then, but that was not a big sell for us to, move everything away. So this is where Graviton came in, and there was a business push where we wanted to get ahead of our competitors and, provide our customers with instance type that they could run their workloads on, which would provide them better price performance ratio. So Graviton provides the around 40% better price to performance ratio, 60% more energy efficiency, and then you would still have options to, have all uh, the classes that your instance classes that you have available on AWS. So almost all of them support Graviton instances, and then even all the open source OS solutions provide support for Graviton ARM64 architecture. So yeah, this was a win-win for everyone. So customers win, even our devs win, and then yeah, we also provide that support. So yeah, it's a win-win for everyone. And even we use that Graviton instances for our workloads for our builds. So moving on, we are going towards the security part of it, and I'll hand it back to Vijay.
Hello. Yeah. So when we talk about security, um, basically we're talking about two things. Uh, First, the images what we are producing is secure in terms of CVE, critical CVEs. And the second thing what we are talking about, the supply chain, what we are having as part of this software delivery in container form factor, how are they secured or to what level they are secured. Okay. So the first part, I mean, we wanted to ensure. I mean, this is just understanding for any of software vendor to ensure whatever they are producing and the consumer, they should be having confirmation and confidence that they're consuming from the same vendor. So this is the second part which I'm talking about. And the first part is obviously the CVE mitigation, which is like the first thing which we hit when we try to do a software delivery using container. Okay. So these are the two aspects what we have covered here, and we'll quickly talk about that. Okay. So the second aspects, what I was talking about is like the Cloudera is producing these containers, and Cloudera is the vendor for those containers. How do we ensure that? So there's a method for that. Like whenever we produce an artifact, whether it's a jar file or a RPM or any deliverable format, we in our legacy format we used to sign it with the proper key and associated with that vendor. That's we all are aware. Similarly, we have a mechanism out there in container signing as well. There's a tool for that, open source tool for that is called cosign, and you can have key and use any key manager. We are using AWS key manager to store those keys and poll and go ahead and sign it. So these are the what. So as far as the signing is concerned, we are using cosign, and now we can quickly come to the conclusion that our images are produced and produced by the vendor Cloudera. So these are the two things what we talked about. We're using cosign and KMS. We'll quickly see the commands what we're using that will uh, okay. So, and this is also a rolling key. This is again another layer of security that the keys are not always constant. It is a rolling key. And these are some additional, once we started working on this area, we quickly realized there are a few other items that needs to be taken care. And we are going ahead and looking at the namespace level as well. Okay. So this exactly is the command what we are using. And it's really easy to understand. We're just exporting the key and using that key through AWS KMS and signing it. So before posting these images to our registry, we are signing it. Okay, so this is what we all talked about. Yeah, and there's a verification process as well at the end of the as the end of the promotion. We go ahead and verify it whether it's a properly signed container key container or not. Okay. So I guess we can we'll just talk about the Kiwano. We are not going to talk in detail about this. Probably you can go ahead and read about it. But this is a way to verify the images what you are consuming in your environment. This will help you out in verifying. Okay. Yeah. So this ensures whatever we are producing is coming from the right set of vendor. That gives you confidence in consuming all those images. Okay, so the first piece, which is the most important piece, what we are always worried about. There are basically two kinds of CVs what we bring in. One from the base images what you're consuming, and the second one what you bring in from your application side. So the base images, though it sounds easy that you can mitigate CVs, what is coming out from the base images, but that's not the case. But the difficult pain point is coming from the app side. Easier to solve out there because those are the things whatever is there in your control. The application is in your control. You can go ahead and fix the kind of CVs what you're bringing in through your applications. We are ensuring both of them. At least we are flagging our app developers in terms of CVs what they're trying to bring in. And we have a policy of having zero CVEs in our base images. Uh, we are ensuring it without fail. And we are using the tools, and there are a hell lot of whole bunch of different workflow in this area. Stay tuned on this. We'll talk about in this in detail. This is not the right forum to talk about. This needs a proper talk about it. Okay, so I guess can we just wait? Uh, I think we'll just quickly roll.
So yeah, so as Vijay talked about the CV mitigation steps and all the how we put security in forefront right from the start. So each of our builds goes through the CV checks and everything. So this is like a high level overview of how we have all of this in our our build process. So this is our on-prem cluster where we run our builds, and we use different tools like Scopio, Cosine, Docker, and this is where we use Kubernetes pods to do our builds, and then here we check. We have the token, and then we check it, and then we pull the images from our internal registry. This is where Harbor comes in, and then we push it to prod. That is the ECR registry that we have, so that our customers can pull in, and then yeah, this is all the signing steps that we do so that we ensure that our images, that our customers know that they are using the right images, and yeah, we ensure that even when we deploy workloads, the right images go in. Yeah, so yeah, so that's pretty much it. So yeah, I'll just quickly summarize it for anyone who maybe came late. So multi-arch is a win-win for everyone. So even for us, our customers, everyone, it's a good thing that we can implement. And then OCI registry, since we moved to Harbor, that's OCI compliant registry that enabled us to provide multi-arch storage, and even store our image signatures that we sign using cosign to be stored in this OCI registry. And then we came across a lot of open source tools that we use, like Scopio, which provides an edge over some native binaries. And cosign also provides signing for secure image delivery. And then, yeah, we moved to cloud native solution so that the and so that we are setup is more reliable, scalable, and cost efficient. Yeah. So for CVs, yeah, one more thing I wanted to talk about. So even Docker has an experimental feature, Docker Scout, where you can scan CVs. So we use a mix of open source and vendor provided solutions to scan CVs, because yeah, we have really high profile clients that we want to ensure that we are on the right track. But yeah, you have solutions where as a normal developer, also you can scan your images using Docker Scout. Yeah. Yeah. So yeah, that's pretty much it. And yeah, if you want to know more about us, yeah, feel free to again stalk us on LinkedIn if you want, or ping us if you want, or catch us after this meetup is done and we could talk about this. So if anyone has any questions, yeah, feel free to shoot at us. Yeah.
One question I had was, especially this vulnerabilities, right? Especially there's a lot of open source component, I think, because the the database of vulnerabilities keep changing pretty rapidly, right? And people do continuous builds. Do you prevent publishing into the container register at the time of build? Because that's one question. And second question is, do you use anything like an AWS inspector to just go and verify the scan, whatever they have deployed, to just make sure that they are up to? That's what I'm trying to understand. Where do you prevent it?
So we have a kind of well-defined rules and well-defined set of tools developed at our end to bring third party and different base images from upstream. We will not be able to talk about the vendor, but we have upstream vendors as well who provide us hardened images, CVE-free images. And we bring internalize those images to our own internal registry with certain workflows and certain processes. So we ensure whatever images we are consuming in our builds to be ready for the applications are CVE free at the top level itself. So we make sure that even if you have having a single CVE, we don't bring that image, and we have a complete workflow of scanning processes for bringing those images in our process. Yes.
What do you mean by CVE free images? Like any base image you take, for example, Linux image or any image that is available in open source, they will have CVEs, but the CVE is categorized as whether it's remediable or non-remediable. So when you say CVE free, do you mean that all the CVEs available in the images are non-remediable?
Yes, we mean it's zero CVE images. There is no CVE in our base images.
I mean, CVEs do exist, right? There is no place where we don't have a CVEs.
Right.
If you take any image, you have a CVE.
Right. So see, first of all, so whenever there is an open source release, first time you release it, you might have zero CVs, right? And then over time you discover there are some CVs.
So I'll just take an example of Ubuntu Docker container,
if
right?
what he's trying to say, today something is not identified, right? It is a CVE unless and until it is identified. That's we understood, right? But when you do a scanning, when your image go through a scanning process, you are right. There are categorization of different CVEs, right? Like high, critical, or what medium, or whatever your scanning process identifies those, right? What we are saying, whatever images we are bringing from top, we are fixing all the critical and all the medium and all the high. So our base images are having zero CVEs.
Okay.
So
if I take an example of Ubuntu, say 20 focal image, right?
Okay.
So if I have to build some image on top of that, my Ubuntu will be a base image, which
Okay.
is published by Ubuntu official registry.
Okay.
And still there will be a CVE, which is not remediable. There is a CVE, but it cannot be remediated. So that's what I am aware of. But I'm not sure whether, I mean, what do you mean by, like, for example, even those non-remediable CVEs are also remediated by, I mean, Cloudera specifically internally and then push it?
Okay. So I will answer your question. The first thing is, look, the thing is, are you aware of the CV database?
Yes.
So right now I will, because I'm using Docker Scout. So usually what happened that if you look at the inner loop side of it, right? When you start building an application, so take an example of React application. Now React Hello World has around, when I ask you to write Hello World example, it has close to 2,420 packages. Now there could be a chance that say you have 20 CVs, right? Now we have a tool called Docker Scout. What happened that even if you go to the registry itself, so when you are using, say you are building some Python application and you found that there are CVs which could be non-remediable. Now that has to be fixed. Okay. So right on your desktop, when you start building an application, the tools like Docker Scout, what it does layer by layer scanning. Okay. And this is not a purely a scanning. It is more like you are trying to match your local SBOM, we call it as a software bill of material, to all those 21 to 22 real-time CV databases. Now, if that CV database reflects that it is not fixable, then you can't do anything.
Yes.
Unless and until you have to wait for it.
Yes.
So as I said, right, now think of it as like just yesterday, there is some vulnerabilities which has been introduced. Now, the only thing is you have to wait to get it fixed.
Yes.
You can't go ahead and package it, but at least you need to ensure that it should not be a critical and high.
Okay.
Okay, it could be medium, it could be low, but if it is critical and high, I won't suggest you to use a base image. Okay. So I can find out with the tools that what are those vulnerabilities. And unless and until it is not fixed, right? So when you go, I don't know whether, have you used Scout?
No, I have not used it.
So Scout basically gives you a layer by layer on your laptop, even before going to the registry. We are not talking about registry here.
Okay.
When you run Docker build command, Scout is already there. You can fix the base image vulnerabilities as well as layer by layer vulnerabilities. Say you are using Node.js. And to fix it, what you need to do, you need to go to the package.json. You have to use the latest version of your software. So when you say Ubuntu is like a base image, but Ubuntu comes with already the packages from the community, right? Say if I'm taking example of Node.js, if you are using the older version of Node.js, definitely there will be some kind of a vulnerabilities, right?
Yes.
But if it's high and critical, then surely the Ubuntu community has to go ahead and fix it. And all you need to do is wait and watch,
okay,
right? So there are two possible ways, whether it is fixable or not. But I can find out layer by layer vulnerabilities out of it. So the only thing is, in that case, I won't recommend you to use Ubuntu. I might recommend you to say you are dealing with Python applications, say use Python, which could be Alpine based. But those 21 to 22 different CV databases, you need to ensure that those vulnerability has to be fixed.
Okay.
Yeah.
Thank you.
Yeah, so in addition to what he's talking about, so you talked about using Ubuntu as a base image, right? That's what we avoid. We don't use that, okay? Right. So as I told you, there is an upstream vendor who is having their own package manager and who is having their own base images, base operating system as well, right? And as he said, like if upstream it is not fixed, obviously we will not be able to get it, right? So there are packages and there are applications which they fix on their own and provide us those patches to us beforehand. It goes ahead to community. Okay, so there is a full-fledged, full-scale vendor for that, and they does this work for us. So what we are trying to say, whenever we consume a base image, it is in sync with what we have out there in an open source mid-tray on any database, what you are talking about, any CVE database, what you are talking about. If they're saying critical, it has to be fixed. You're right. There are certain things which has not been identified. Today, it is there. Probably tomorrow, it will be a critical CVE. We don't know exactly, right? Unless and until it is identified, which you already told about you, it will be fixed. If it is identified, it will be fixed. Unless and until it is fixed, we will not be going to consume those images. Okay?
Thank you. Thank you so much, Vijay and Philemon. Thanks, Ajit. So in case you have any further queries, please reach out to them towards the end of the session. In respect of time, we have to move to next talk. Thank you. I request Vikram. He works for Dagger. He will start with his quick introduction. He will go for the next talk. Thank you.
I'm going to do a test.
Hello. Okay. Hi. So hi, my name is Vikram. I'm from Dagger. I'm a developer advocate at Dagger. And topic of today's talk is CI pipelines, but not just CI pipelines, but making CI pipelines faster. And normally I like to start this with a simple example. Maybe a picture is better. Yeah. So if you look at this, this is basically how CI pipelines start and how they end. So imagine you're building an app. You start off with a pretty simple pipeline. The thing you see in the corner, it's a factory. It's producing containers. It's sending those containers out. It's deploying them, et cetera, et cetera. It's really neat. You know, it looks very organized and so on. But then time passes. Sorry. Okay, is this better? Okay, cool. Okay, so like I was saying, so your CI pipeline starts out looking really nice, systematic, etc. And then you add features to it. You want to do more things with it. You want to do security checks. You want to do linting. You want to do testing. You want to do all kinds of stuff. You want to add, and you're also adding features to your app as well. And it becomes more and more complicated. And this is kind of the progression that we often see. It starts off, you know, day one, you see the smiley face, looks great. It gets more and more complicated. And at some point, it becomes so complex that when you look at it, it's very hard to understand what the pipeline actually does. And it becomes like, you know, the monster in the cave, which no one wants to touch. It's always the people think, hey, it's working. Let's not get into it. Let's let it run. And by the way, what you see, the large day 401, I'm sorry to say this is an actual pipeline that we've seen running at a client site. Some parts of it have been obviously obfuscated, but it's actually longer than this. And so you can imagine that debugging this kind of pipeline is very difficult. So, so we asked the question, what's wrong with CI? And there are three patterns that we see, three patterns which come up very often. I don't know if anyone is familiar. Look at the screenshot. How many people are familiar with this kind of GitHub commit log? Put up your hands. Yeah, okay, cool. So you guys know what I'm talking about, right? Works on my laptop, does not work in CI. We call this the push and pray problem because the developer is writing code, he's testing it on his laptop, he's pushing, and then he's praying to the CI gods that I get a green signal at the end. And when it doesn't, then you see this kind of sequence. Second pattern that we see very often is lock-in. If you invest a lot of time building your CI pipeline in a specific CI provider, let's say GitHub Actions or GitLab or anything like that, and you've got a reasonably complex pipeline or you've got multiple pipelines, you have this lock-in problem. If you want to switch to a different CI vendor, it's a massive investment of time in re-engineering those pipelines. It's not very easy to do. There's a lot of testing involved. very often you're running your old pipeline and your new pipeline in parallel, while you're testing and making sure that everything is working properly. And so vendor lock-in is also a problem. And this is, I've taken the same pipeline that you saw a few slides ago. And if you look at the top, it's basically a debugging problem. There's so much code, there's so much complexity in today's CI pipelines that it's very hard to understand what is happening. It's very hard to debug it. It's very hard to pinpoint where an error is and to find the right people in the team, maybe with that specific knowledge for that specific part of the pipeline to help you solve it. And so the insight that we at Dagger have had is that pipelines are just like applications. They're complex. They're difficult to debug. They have lock-in issues. They have this works on my laptop, doesn't work in CI problem. And these are all problems that used to exist with applications. If you guys remember, maybe before Docker came out and a new developer joined your team, and you spend a lot of time with them, or they spend a lot of time setting up their machine exactly the right way with the right configuration files, everything in the right place, et cetera, et cetera. And then Docker came and it made it much simpler because it gave you standardized environments that you could just run. And our insight is that pipelines have the same problem these days. And what you need is, just like Docker is a container engine for applications, you need a specialized container engine to run pipelines. And that's where Dagger comes in. So it's a completely new way of creating CI pipelines. You containerize your CI pipeline, so they run a container and they always work the same way. So I'll walk through this a little bit because this is quite, there's a lot of different components to Dagger. And so we'll start with the center, which is the Dagger engine, which is our open source container engine. And what this does is that it lets you create your pipelines and run your pipelines in containers. And those can be run both locally on your local machine, and they can run on in a CI platform. And because it's containerized, it works the same way in both places. So that means that you no longer have the works on my laptop problem. The minute you run your pipeline locally, you will see whether it runs or it doesn't run, or it succeeds or fails. And if it succeeds, since it's the same pipeline running in a container in your CI vendor, you know it's going to run the same way. So in order to create those pipelines, we have SDKs. And I'm going to show you a couple of examples. I've got a live demo, so we're going to see some of this in action. But we have SDKs which let you construct your pipeline using, we have three languages which are officially supported, which is Go, TypeScript, and Python. And we have an open source community around our product. And they have produced other SDKs. So we have an Elixir SDK, we have a Java SDK, we have a PHP SDK, and there are more SDKs being produced by the community. So that takes care of the pipeline part of it. And our because, as I said, runs in containers, we are actually CI agnostic. Once you write your Dagger pipeline, it will run in every CI that exists, and it will also run on your local machine. So if you decide, for example, that you want to switch your pipeline from GitHub to GitLab, or from Circle CI to GitLab, it's the same Dagger pipeline which runs in both of them. There is no re-engineering required. The third component that we have is Dagger Cloud. So Dagger Cloud is our cloud-based dashboard, which lets you view your pipeline in real time as it's running. You get a complete trace of what your pipeline is doing, all the functions that it's running, and you can drill down and see exactly what is happening at every stage, and also see what errors are happening. Because it's a web-based dashboard, it's also very easy to share a specific trace, which is a debug run of a pipeline. You can share it in your team. You can share it outside your team. And I'll show you some of those as well. And the final thing is the Daggerverse. And what the Daggerverse is, so Dagger functions, which is you construct a pipeline using Dagger functions. And Dagger functions can be packaged and shared. So we have the Daggerverse, which is our catalog of Dagger functions. And so I'll just give you an example to make this clear. Let's say, for example, you have a pipeline and your pipeline needs to upload an artifact to Amazon S3. Now, you could write an Amazon S3 upload function in Go or TypeScript or any language you wanted and put that into your pipeline. But we have the Daggerverse, and other people have already done this. So you can just import one of those S3 modules into your pipeline and use it. And you can just plug it in just like you plug in Node.js packages or PHP packages or Java packages, you just plug them in. So it's a full ecosystem of modules. And I'm going to show you some of that as well. So I also want to mention, so as I said, the Dagger engine is completely open source. Dagger Cloud is free for individual users. There are no caps. And if you're working in a team, we also have a team plan, which makes it easy for people to collaborate on debugging pipelines and sharing pipelines and so on. And all modules in the Daggerverse are open source. So when you go to the Daggerverse and you see a module you want, we have a link to the source code, which is on GitHub. So you can always go in and look at the module source code and make sure it's doing what it's supposed to do. And before you decide to use it in your own pipelines. So since the title of my talk was basically Dagger on Kubernetes, so let's talk a little bit about Dagger on Kubernetes and when would you want to use it? So like I said, you can use Dagger with any CI vendor. You can use GitHub, GitLab, etc. But you may also want to run it on your own Kubernetes cluster. There are a number of reasons why. Maybe you have specific performance needs. You're running very large workloads, or you're running a very large number of workloads across the enterprise, and you want to put it on Kubernetes because maybe you already have a Kubernetes cluster and you want to use that. Regulations for some industries, maybe you're not allowed to run your pipelines on public cloud infrastructure. So you need to have your own private cloud and you want to run it on that. As I said, maybe you already have a Kubernetes cluster using internally, you want to use that. Maybe you just don't want the vendor lock-in. You don't want to say, well, I'm stuck with GitLab, I'm stuck with GitHub. I want complete portability. I want complete control over my pipeline infrastructure. And so you would use Kubernetes for that. So that's actually the end of my slides. And what I'm going to do now is we're going to do a little bit of a live demo. So I'll just explain to you a little bit about what this is. I have set up a Kubernetes cluster, which has Dagger installed. It has Argo workflows and Argo events installed. And I have a GitHub repository, which is connected to Argo events. And what we're going to do is we're going to actually run a couple of pipelines. And in the process, I'm going to show you a little bit about how Dagger works. And at the end of it, we'll also see whether the title that I put, which is Supercharge Your Pipelines, whether that was true or it was advertising. So let's go. Hold on. Sorry, guys, having a little trouble with this. Okay, so what I have here, this is a sample app. It's a Java app, which is the Java Spring Pet Clinic app. Some of you may already be familiar with this. And what my pipeline is going to do is it's going to use Dagger to build and publish a container of this app. And so what I've done is I've written a Dagger pipeline in Go. And I'm putting it up on the screen so you guys can see this. And so this is a pipeline which has two functions. There's a build function and there's a publish function. And if you're familiar with Docker files, when you look at how you build a Docker file, you build it in layers. And Dagger's APIs kind of mimic that. Because what we're doing is we're chaining together different function calls from the API to construct a pipeline. And so if you see DAG is our entry point to Dagger, and we're using a Java module, we are saying we want to use it with JDK 17. We want Maven 3.95. And we are passing an argument to this function, which is source. The source is the source code that we want to build. And we are outputting a file, which is a jar file. So we're going to run Maven package in a container, and we're the output of this function is going to be a file, which is a jar file. We also have a publish function, and let me make that a little bit. Yeah. So our publish function actually starts with Eclipse container. It actually calls the build function to build that file that we wanted and puts that built jar file into the Eclipse container, sets up the entry point, and publishes it to a public container registry. So we don't need to I don't want to get into the details of it because we don't have enough time, but feel free to ask me later. But this is an example of two Dagger functions written in a programming language, which is Go. The advantage of using a programming language for your pipeline is that you can do a lot of things which you couldn't do earlier. So for example, if you're using an IDE, you get automatic type hinting. If you want to debug it, again, the IDE will help you. If you want to use external modules in that language, you can just plug them in because this is just regular Go code. So if, for example, you want to integrate with Google Cloud, you can download and import Google Cloud libraries into your pipeline and just use them because it's just a regular Go program. So you have access to your language's entire ecosystem of modules when you're building a pipeline, which is something you don't usually get when you're trying to build a pipeline on a GitHub or a GitLab. So this is our Dagger function. And let's flip back a little bit and go back to the Kubernetes setup that I have. Yeah. So this is the Kubernetes cluster that I'm going to show you. We have GitHub as the source code manager over there. It's connected to our cluster. The cluster is an ingress. We have Argo workflows, which is controlling accepting jobs and controlling the running of the jobs. And all those jobs are connected to the Dagger engine. And there's a service in front of the Dagger engine. The Dagger deployment here is a stateful set. So it's running on a single node. And the reason that I've used a stateful set deployment here is because Dagger provides a lot of built-in caching features. And that cache is going to be stored on the node. So for example, if you had multiple nodes, you don't know exactly where your job is going to land up on which Dagger engine. Whereas in this case, it's all a single node. So we know it's going to use the node cache for subsequent runs of the pipeline. So what I'm going to do, I'm going to put down a mic. So can you guys hear me at the back? Okay, because I'm going to type. So I need both my hands. So let's look at. So let's look at what we have on the cluster. Oh, okay. Okay. Okay, I'm going to try and type with one hand. Okay, so it's going to be a little slower. So this is our cluster. It's got these namespaces on it. And what I'm going to show you is we have a Dagger engine pod running in the Dagger namespace. And what I'm going to do right now is I'm going to kill this pod so that a fresh pod starts, so that when we're doing this demo, you see it like with a fresh cache. Okay, so we're going to delete this pod. Keep an eye on it. It's going to come back up in a second. And there should be a new one starting. And the reason I'm doing this is so that it starts with a fresh cache because we want to show you the speed. So you can see it just started 7 seconds ago, and we're waiting for it to start. Sorry? No, it's okay. It's fine. Thank you. All right, let's push a change. Where is our, I'm going to push a simple change to this file here. Okay, we're not doing anything fancy. We're putting a couple of spaces into it. And we're going to say update. And now what will happen is when this commit hits the GitHub repository, there's an Argo event watcher on that. So there's a webhook. The webhook will trigger and it'll trigger the Argo event watcher. And this will actually start a workflow. And we can see that in action. Yeah, so you see there is one workflow running, and that's the one that was just triggered. And what we can do now is we can actually look inside it and see what's happening. And if you look inside it, actually, when we look in it, you'll see that it's actually running a Dagger pipeline. And what we can also see with this is I'm going to show you Dagger Cloud, which is also going to be showing what's happening. So let me go here. And this, by the way, this is Dagger's own dashboard. So as our team is working on Dagger, our dashboard is public. So on the left side, these are actually pull requests in our own public repository, which as people are working, you can see them. And on this side are the local runs. So people who are running it on their local laptop. And so the first one that you see, the yellow blinking one, is the one that I just started. And so we can go into it. I wait for it to load up. And so this is what we call a trace. We actually use OTel under the hood to handle these traces. And you can see exactly what is happening in the pipeline, how long each of the function calls is taking, and you can drill in to quite a level of detail. So let's look here. So you can see it's actually getting Maven packages right now. And if we go back in here, we can see in the pod itself, what is you can see the log of what is happening. So when I tested this just a little bit before, it takes about 3 minutes to run. And I think it's at 1:30. So we have 1.5 minutes. If someone wants to ask a question, you have 1.5 minutes for you to ask and me to answer while the pipeline's running. Do you need a mic?
Are the build files only in Go, or can you write them in YAML and all of that?
Sorry, we actually actively discourage the use of YAML because it's very difficult to actually work with YAML. But you can write a Dagger pipeline in any of the supported SDKs. And one of the cool things that I didn't mention is that when you write a Dagger function in a particular language like Go or TypeScript, you can actually import it into Dagger functions written in other languages. So for example, if you have 2 or 3 different teams in the company, some are using Go, some are using Python, some are using PHP, etc. Let's say one team writes their functions or their modules in Go. Another team wants to reuse their work, but they don't know Go. Maybe they just know TypeScript or Python. They can actually reuse and import the Go module in their Python module, and Dagger takes care of the language portability issue. Okay. Because behind, at the back of Dagger, we use a GraphQL API. So all the SDK API calls are translated into GraphQL API calls. So we're able to actually manage a cross-language ecosystem.
Okay. So do you add support to new languages, or is it?
Sorry, I can't hear you.
Oh, do you actively add support to new, let's say it's a less known language like Zig, for example. What's the model then? Like, do we have to wait for Dagger to add a support for Zig, or is it?
Yes. Well, so there are 3 options. I love the first option. I want you to start that Zig community and create a Zig SDK, and we will put it on our website. So that's preferred. But in the event you can't do that, so there are 2 other options. You could obviously write in one of our supported languages, Or actually, you can our GraphQL API is actually on a client server model.
Okay.
So if if Zig has a regular HTTP client, as in the programming language, you can actually make HTTP calls to the Dagger server and communicate that way. And just a personal story, like I'm a PHP developer. I've been a PHP developer for a long time. And when we started, we didn't have a PHP SDK, but I still was able to write a pipeline using a HTTP client in PHP and just communicating with the Dagger server using raw GraphQL. So it's a little bit more tedious. It's not as neat as what you saw because it's not, you're not calling APIs. You don't have the IDE support and all of that stuff. You're just making GraphQL API calls, but it's 100% doable.
So Dagger Cloud itself is open source? No.
Yes.
Okay. Okay.
I can show you okay, so I'll show you the repository. As you can see, guys, this pipeline took 3 minutes and 24 seconds. This is the first run on a fresh pod. And now what we're going to do is we're going to run it again. And I want to show you Dagger's caching. And we're going to come back to the first word in my title. And you're going to tell me if I spoke the truth or not. So let's make one more change. And let's commit that. Okay. And let's go back here for a second. So this was the trace which we just saw, and there should be a new one starting in a second. So as you can see, this took 3 minutes, 24 seconds. And we can see if there's a new one started. Yeah, so you can see there's a second one started. And before we move forward, let me ask you a question. If I can find my slides. Right. Quick poll before the pipeline finishes. How many people think it's going to take less than 30 seconds to finish? Hands up. Okay. Very few disbelievers. Okay. 30 to 60 seconds. Okay. More. 60 to 90 seconds. Okay. About an equal. 90 to 120 seconds. No one. Okay. You got faith in Dagger. Or maybe it's the other way. 120 to 150 seconds. Okay. So I think the consensus is that it's going to be somewhere between 30 to 90 seconds. Is that right? Between 30 to 90 seconds. Everyone put your hands up. Whoever said that. Okay, I think that's the consensus. Let's see how long it actually took. Hold on a second. Yeah, about a minute. So we went from 3 minutes, 24 seconds to about a minute. We can check the exact time because we have a trace. Where is the trace? So this is the second run. And this is all because of Dagger's caching. You can see it took 1 minute, 11 seconds, so about 70 seconds. So you guys who said between 30 to 90, thank you, you were right. This is because of Dagger's caching. We have two layers of caching. We use BuildKit, so we have BuildKit caching. And then we also have our own cache volumes, which are used for caching packages. That's what I used in this function. And that's why if you actually look at how long the package installation took, let's have a look at that. And normally in a Java app, this thing takes quite a lot of time. You see in the second run, it took 59 seconds. And if you go back, and let's look at the first run. And we can drill down into the trace. Yeah, so you can see it took 2 minutes, 30 seconds on the first round. So we managed to cut that quite a bit. And that's entirely down to Dagger. It's the same cluster, it's the same infrastructure, everything's the same. The only change I made was I just submitted again with a small change. So that is my demo. Let me go back to my last slide. So if you're interested in Dagger, we have a Discord. So Dagger is open source. We have an open source community on Discord. Please join. You can ask questions. Our entire team is there. We are out to help people. We also have a quick start for people who are just new to it. A quick start takes an example app and walks you through building a very simple pipeline. It's a Node.js app. You build a pipeline for it. It takes about 20 minutes to complete. And it gives you a pretty good walkthrough in how Dagger functions work. I'm open to questions. I don't know how much time we have.
Yeah, slightly basic question. So what alternative software like Tecton or Spinnaker, like, or maybe they're very different. What are the alternative software and what are the advantages Dagger gives over them? Is it just caching or is there more? Or because there seems to be a crowded market for this sort of CI/CD. Correct me if I'm wrong. Yeah.
It is. There are many tools. We don't think anyone has this particular combination of things. So for example, we have a cross-language ecosystem where you can use pretty much any of the supported languages to write your modules and have them used by other languages. We have a complete debugging and tracing system in cloud. We have the engine itself, which is a way to run pipelines and containers, which is something quite unique. And the SDKs, which provide you a way to create pipelines in a way that's not been done before using program code, just like you would write a normal program.
Okay. So oversimplifying it, you mean like the SDK is the key benefit of multi-language support, or is there?
Well, actually, it's the GraphQL API which enables the multi-language support.
Okay, so that talks to GraphQL and then.
Yeah, so we have our engine itself has a GraphQL server, and our base API is in GraphQL. So the SDKs are simply wrappers around the GraphQL API. And that's what makes it possible for when you call a Go function, we are translating it to the GraphQL API. When you call a TypeScript function from the SDK, we're doing the same thing. So that's why we are able to handle modules which are written in different languages in the same pipeline, which enables a huge amount of reuse. And we also have this, I actually didn't get a chance to show it, but I can show it now. So we have I mentioned this, that we have the Daggerverse. And the Daggerverse is basically a huge collection of modules. So I'm just going to scroll through it so you guys can see. These are all community-generated modules. This is our community at work. Usually, if there's something you want to do in a pipeline, chances are good that there's a module here. Sometimes you'll find more than one. And this kind of plug-and-play ecosystem is, again, something that's not readily available.
So slightly indirect question that might be slightly difficult to answer, but let's say you have a customer running on these other software, right? How do you convince them to shift to, let's say, Dagger or something like that?
We ask them. So the way we normally encourage people is if you have a problem, a really urgent problem with your pipeline, we encourage you to try Dagger. Sorry?
Problems could be, sorry.
So it could be anything. Maybe you're having a specific speed problem. Your pipeline takes too long. And you identify it to being a specific part of the pipeline which is taking long. That could be one example. In that case, we would say, take that segment of your pipeline, rewrite it using Dagger, and see how much the caching helps you. A lot of people have done this. We've had people who their pipelines take 40 minutes and they've come down to 5 or 6 minutes just because they identified, okay, this part is slow. We rewrote it in Dagger. The caching made such a huge difference that they were able to, reduce the timeline of the pipeline that much. And then the next step is once you've written a part of your pipeline in Dagger, you kind of expand outwards and you say, okay, I did one step. Let me translate the next step into, converting it from YAML to code. And then you see that works. And then you keep going. And finally, you have what we call a Daggerized pipeline, which is your entire pipeline is written in Dagger. We don't normally suggest going all in and saying, I'm just switching to it tomorrow. We don't encourage that. We do encourage starting from the problem area and kind of expanding outwards.
Thanks a lot. Yeah.
Thank you so much, Vikram. In respect of time, we are anyways late. If you don't mind, please connect with him.
Yeah, I'm here for a bit, so feel free to come and
Yeah. Thank you so much, Vikram. Thank you, everybody. I request Ravindra and Ajit to go with the next talk, please.
Hey everybody, thank you so much for coming on a Saturday afternoon and taking time to, attend this meetup. I'm sure most of you will not go out disappointed. There's a lot of stuff that we're going to learn here, and it's going to be pretty exciting. I don't want to break the surprise in this place. So myself and Ajit will be presenting on something that is called as Model Context Protocol, or MCP, which is almost the latest topic. We can see, it was introduced in the January month. This month, I mean last month. We are already in February 1st. So I'm still in January. So as such, this is the first thing. Okay, so hang on. Before we go ahead, I just want some more energy. I'm sure most of you would have seen Pushpa 2, right? How many of you saw Pushpa? Most of them? Okay. So repeat after me. Containers rule. Come on, energy, guys. Containers rule. Awesome. Once more. Containers rule. Containers rule. This side is having more energy or this side is having more energy. So we'll start one side telling containers are cool, one side telling Docker is cool. Okay. So we'll see who has more energy. Come on, guys. This guy has more energy. I think we have a clear winner. Okay. So I'm Ravindran. So I have almost 18 years of experience. So I'm a senior consultant and a project manager in Blueprint Technologies. So I do quite a couple of things. And I'm really passionate about technology. And thanks to Ajit, I've been with the Docker community for quite some time now. And it's been, a wonderful journey. Next, I guess we have Ajit.
Yeah, hi everyone. First of all, thank you so much for coming today. Okay, so I am Ajit. I am part of the DevRel team at Docker. So I have been using Docker when Docker was just like 1 year old. I've been writing about this technology, about this product, about the CLI. And I'm also a former Docker captain. The reason being, when you are a Docker captain, you can't be an employee at the same time. So I have to leave the captaincy and be a full-time with Docker. I'm also a Docker community leader, which means that we organize a kind of meetups all across the globe, not just in Bengaluru. I'm also a distinguished ARM ambassador. So there are around 13 to 14 distinguished ARM ambassadors. They are like work very closely with ARM. We do a lot of POCs around running containers on IoT devices. So if you use Jetson Nano or Raspberry Pi, and if you want to know more and more use cases, you can reach out to me. So we do a lot of stuff. In the past, I worked for Dell EMC for almost like 8.5 years, VMware and Redis. And if you want to get connected to me, this is my Twitter handler, Ajit Asurena. So we can get connected. Now with this, I would hand over to Ravindra.
Thank you, Ajit. So, let's talk about generative AI and rise of generative AI. I mean, why do we need generative AI? I mean, AI is a pretty old concept. It's almost in the 60s when, a person called Alan Turing started, AI. So at that point in time, we did not have the infrastructure. And basically, the magic happened when Google started introducing what is called transformers in 2016. From then, the magic happened. So with generative AI, we can cater customized solution. So for example, I want an image of, a tomato that looks like a rabbit. That's pretty crazy, right? So I can do that in generative AI by, a lot of models, ChatGPT, DALL-E. There's a lot of things. So basically, generative AI it can create any kind of content. So when you talk about content, it's going to be audio, visual, or textual as well. So if we want to summarize the text, read one whole big document and say, what does it say? I don't want to read all the 100 lines. Or, act maybe a question and answer. You're writing one exam and there's 100 PDF. You don't want to do Control F, Control F. You directly answer the question. So that way, this is pretty useful. And yep. So this is generative AI, our brain, which has a lot of algorithms, large language models, image models, vision models, etc. So with this, we can generate summary, we can write code, we can, produce any kind of audio, we can make it, recognize what audio we are telling, chat with us, quite a lot of things. Okay. So all this sounds very interesting, but how do we maintain a good AI system? Okay, so how do we leverage the maximum, make sure that we have the highest use of it? So first thing that is very important is data. So if we feed it the right data, that's when it's going to give us the right information. So we should have a data pipeline that has the relevant information. So if I say generative AI or AI for that matter, it's just like a glorified calculator. If this, not that, if this, not that, and they have quite a lot of things. This is a very oversimplified explanation for that. So it's required that we give it the right set of data so it can make decisions. Okay. And also, sometimes we don't want it to make the decision in a certain manner. Like, for example, I can draw parallels where we say, hey, you know what? I like more sugar in my tea. You might not like more sugar in your tea. So like that, there would be change in decisions the model makes. The model would have been built with an intent. We can customize it. We can retrain it. If you guys want to know more about this, definitely, visit our Collabnix page. We have our Collabnix YouTube channel also, where, there's a session on generative AI 101 and 102, where we have all these things. Apart from it, there are many interesting videos on Docker. So after we, do this training, we need to integrate it to any kind of applications. Now, if you want real-time information, say I want to know what is the sales at this point of time in my organization, or how many people are logged into a particular server, etc. Or maybe the stock market. I want to know what is the last 15 minutes stock market. So that's not possible because whenever AI, this kind of generative AI models or large language models are built, it is basically it has a knowledge limited only to the time where it was built. For example, when GPT 3.5 was released, it had information only till 2019 or 2022 as such. But we were in 2023 when we wanted the latest information. So stuff like we ask it, okay, give me the latest date. It cannot give those kind of information. So we need it to be integrated to our applications so that it gets real-time information and it gives what we want. So um, just a spoiler alert. The next couple of slides that we are coming, we're going to talk about MCP and how crucial this is in terms of integration with applications and getting what we want. So we can integrate with applications via API, real-time data processing, and of course, it should be a scalable solution. Okay. And then, yes, next thing is ethics. With the AI model, we trust so much of this AI. We chat it and say, hey, you know what? What is the best place to go in Bangalore? Okay. So it should give us the right answer. It shouldn't give a biased approach based on whatever it was trained. So it was trained telling that, okay, MG Road is the best place to go. Nothing else is the best place. So that's a bias. So we need to keep in mind the ethics and security when we are working with this kind of thing. So it provides any unbiased content and, as per local laws. There are laws that also that we have to follow where, I cannot say write a poem against the government. It should say, no, I'm not going to write a thing. You can see that in the OpenAI or Copilot. You can see that it says that. Apart from it, one more important point that is there is data privacy. So whatever I'm telling is going to be my IP or my intellectual property, or whatever data I'm providing a set of log files and saying, hey, analyze this and come back and tell me. Or I'm giving an Excel file and say, hey, these many Excel files, merge it and do something out of this and say. So there should be data privacy such that you don't lose your data, or if you're, giving it for your customers, you don't, put their data in jeopardy as well. Okay, after this comes, we built the AI system, it does all these things, great. We need to make sure that, the system is up and running always. How do we know that? We have to monitor it and avoid any kind of issues come in advance. Okay, saying that, hey, you know what, these are the things I'm going to monitor. This is basically towards the infrastructure side. I'm sure most of you, do it day in, day out. So we just have to make sure that the underlying infrastructure and the model and other details are tested for any kind of potential issues that we see in the future, and try and avoid that. Apart from issues, we can look at how we can enhance it. So today it can do A, B, C, D work. So why not make it do extra E, F, G, H, increasing its capability here. Okay, so that's on this part. Now let's talk about when it goes to generative AI, it kind of started in some way, and then it moved along to what we have right now. So here, since most of the generative AI topics are pretty new, I might miss something, so please bear with me. So whatever we have got until now, I've taken that. So say it's the brain. It has all the algorithms, all the data, whatever is required to create stuff. We spoke about it in our slides previously. So that started generative AI. One question that more that will hit most of us is, hey, you know what? I typed the text. How did it understand what text I typed? I just typed the plain text. I know maybe in some wrong grammar also. How did it correct it? How did it know, what is the information? So as we all learned in our early school age and stuff like that, computers understand zeros and ones. So it converted this information into vectors. Okay. So it converted this information to vectors. Now we also have something called as a graph database, which is an advanced database. So some of the examples are Cassandra, Neo4j. These are all examples of graph databases. When you go to vector databases, Pinecone, Chroma, okay, these are all databases. So some of the, and even Superbase, for example. So all these databases are available at a free tier, or if you guys have Docker desktop, you can install these extensions and test it on your local system if you're more curious about what is the database I'm talking about. Now, when I say vectors, some people will say, hey, you know what? Some of them might have understood, some of them might not. So let's imagine, if I'm saying the AI, this is the property of a dog. This is how a dog should look. This is how a cat should look. So it will have different kind of parameters. So I'm sure most of us in the school times, you would have heard that, vector is the one that has direction and magnitude, basic definition that we would have heard. Okay. So in this, we have a particular vector, plus we have some kind of information. Now, rather than going into this, let's take a very simple example. We all might have seen this throughout. So you all are familiar with RGB, red, green, blue. Okay, so when we combine a certain magnitude of red, green, and blue, it results in a different color, right? So let's imagine the red color being one axis, green color being one axis, and the blue color being another axis. So as the value of all these three parameters change, the color output is different. So similarly, what AI understands, when we provide the input to it, there is a certain thing where it converts our textual language into these kind of numbers. It's called an embedding process. Okay, so more about this is still there in the talk on Gen AI 101. Please look into that. Considering the time limit, I'm not going in depth in this place. Okay, so after embedding the data or making it digestible or understandable to the generative AI model, we will this will actually push the information to the model, and the model will, based on its information, it will reply back telling that, hey, you know what, this is what is the answer that you're looking for based on the query. But what about real-time information? So that's where we store this. And of course, for doing this kind of embeddings and other things, there's a framework called as LangChain. Okay, so we can to describe it in a single word, it's like a Swiss Army knife. So it has all the tools that is required to build an AI application. Okay, we'll actually delve a little bit more detail on that. However, apart from these frameworks, we have this real-time information would be stored into a database after it gets processed by this LangChain. So say you give a document, it will ingest the document, create embeddings, and put those embeddings into a database. So what kind of database are we looking at? Neo4j or Pinecone. So that's the icons for that. So then you can have a question answer session. You can have a summary, sky's the limit. And it depends on how crazy you are to what limit you want the AI to perform. Okay. So after this is what we started with RAG, or retrieval augmented generation. So when we ingest a document, ingest a video, ingest an audio, so most of you might be using the Copilot, right? In the Copilot, you have an automatic summary, and then you can also integrate it with your tasks. It gives you at the end, hey, you know what? These are the points in the meeting. This person agreed to do all these things. This person spoke this. This person did this. So all this is possible through, generative AI and to a certain extent, RAG. Now, after RAG, I mean, most of us are greedy. We want more from less. So the next step that we took is say, why can't I integrate this to different tools? Okay, and uh, uh, we have a bunch of code developers who are here who like to write code and do things. There are some more people who are maybe a little semi-tech. They like to, do something like no code, which has also been a buzz for a couple of times. Okay, so we have Flowwise. Has anybody heard about Flowwise? Anybody? Okay, so imagine a PowerPoint kind of thing where you just drag and drop the components and connect it to your large language model. You can build an entire workflow straight on it. Okay, so you don't need to write a lot of code on this. So another is Langflow, which is also a very popular tool. Then we have Power Automate. I'm sure you guys have looked into Power Automate. If you have Microsoft 365 subscriptions, you'll have Power Automate, which is mostly a part of Office 365. If you get a chance, just explore that. We also have N8N. N8N is also another workflow automation tool. You can connect LLMs inside it, and give a lot of make it do a lot of things. We also have OutSystems, which is also another what do you say, low code, no code platform. It's used for this deployment and most of the infrastructure support activities. Now, after this AI integration tools, things started getting a little bulkier. Now we have code, we have frameworks, we have data, we have all these things, but I should sit and configure all these things every time. And when there is a new requirement, again, I have to do the same thing. So we got something called as agentic AI and context MCP, which is the context protocol. So first, let me talk about agentic AI. Now, if I give the AI about 100 tasks and ask it to do those 100 tasks, it doesn't know what sequence this task has to be done. Okay, and which task? Now, some of the tasks I would describe in a very the way that I understand. How do I make the AI understand that? Okay, so we had different agentic agents which would be connected to the LLM and the AI model, and it would go back and report. The LLM would basically say, hey, you are agent 1, you will do this. You are agent 2, you will do this, and then report back to the main controller from where it goes forward. So imagine AI doing all these tasks at the same time. Okay. So every time we had to build something customized because the whole concept of generative AI stands on customization. Okay. So every time we want something more customized, think of this: if you are going to provide this solution to your customers, or you are yourself a customer, you'll say, hey, you know what? It'll be nice if I have one more extra feature inside it. So that's where we started Claude or Anthropic started what is called as MCP, or Model Context Protocol. So any questions until here? We'll pause for a brief 2 minutes.
AI agents are required to do specific tasks in something. Who is doing orchestration of all this tasks being done and getting the data in case if some agent fails? How does it happen in this?
So there is actually a framework for it. So there are
Okay.
different frameworks. Now, if you go to Langflow, Flowwise, all these places, you have like drag and drop. You can put all of these. Okay. There's another one called as a Lang graph. What you need to do is you need to set up LangChain, you need to set up Lang graph, and there is a separate GUI tool that is available only for Mac users. It's still not available for Windows users. So it brings human in the loop. It's actually a very vast concept.
Right.
So to make it very simple for our things, we can use any of these that that'll do the work for us. But the upcoming slides, we'll see that how we can do that on our local system itself. We don't need to, have heavy infrastructure. We'll see how we can do it in our local system itself. So I think let's have an energy check. Containers rule. Docker is cool. Low energy guys, come on, let's buck up. Okay, this side wins. Again, come on guys, next time when I do the energy check, I want this side to win. So I don't know about you guys, but I got a common doubt. Hey, you know what? LangChain, MCP, and N8N. All of these do the same thing, right? What's the difference in it? Correct? I need some kind of comparison on that. So LangChain is a framework, MCP is a standard, and integration tools are workflow automation. So let's actually understand more on this. So you see the doll here, it's like a stuffed toy. Okay. So the stuffed toy has a standard parameter where it says, okay, you can use it in a certain way. You cannot make it a car. It's a doll. So you got to use it like how you're going to use a doll. Okay. It behaves. So basically, if I go by the standard definition, it has formal set of guidelines, and we know what is the expected input and output and how it behaves. That way it's more predictable for, the solutions that we are going to introduce it to. And that way it ensures that if we know what is the input, what is the output, what is the behavior, we will have better control and interoperability, and we feel secure on things that we know already. If something we don't know or unknown, we kind of have a small insecurity in those. Okay, so same thing, imagine this doll. Can anybody tell me what's the difference between both of these? Sorry? That's made of Lego. Who said Lego? Hey, good observation. So this is Lego. So when you go to LangChain, we build the component brick by brick by brick. Okay, we have everything that we need to build brick by brick. Here in MCP, we already have it. Certain things that are already straightforward and standard. Okay, so this is like the Swiss Army knife that I told you. It has all the tools and functionalities to, simplify the AI application development. And this is mostly like a, extra stuff, that accelerator that is providing reusable codes. Now, finally, when you come to integrations, can somebody tell me what's the difference between, I mean, what's special about this doll? Sorry? You assemble, correct. So it's like a DIY project. Okay, so it's like a DIY project. So when you go to your workflow automation, you do a DIY project. You take different components, you assemble, and then you make stuff out of it. So what is the main purpose of this? This provides seamless data exchange because we are using DIY to connect many systems. And this is mostly for process automation. You want to automate a particular process. Like, let's say in your company, there is a RFP or request for proposal where you're saying, okay, what should I answer to the customer when I get a RFP? So that document has to study, I mean, GenAI has to study the entire RFP and then reply to the RFP by generating another document. Okay, so this is the entire process. So we do one by one, and then move forward. So this is one good example of the process automation. And we can also, do look at decision making rather than training models, which is quite expensive. While looking at the infrastructure, we can look at enhanced decision making. We can say if the RFP's from value is less than $50,000, don't touch it. I don't want to waste my Gen AI for value of anything that is less than a certain amount. Okay, so this way I have any kind of data error people entering it, I can reduce that, and I can ensure that the data is consistent. Sorry? Faster. Okay. So what's so special about this model context protocol? Okay. So we can see that, it's an AI system that actually provides context. So can somebody tell me what's the meaning of context in this place? Okay. Some more? I think, sorry? Previous information, understanding what is in the environment. Anything else, guys? Related information. Sorry? Adhering to rules and framework. Explaining more. So yeah, all of the answers are kind of correct. But just imagine if somebody, most of you have studied a science stream, I believe, right? So if somebody comes and tells you, teach me math in 10 minutes, what will you teach them? You need to ask, what is the guidance that you need? So AI systems have so much of information. They don't know what to do. When we ask them one, they have a million things that they can say. So this model context protocol helps us in guiding the AI system. So I have my Gen AI model. I have, existing data. This is going to help me or guide the model as to what it has to answer, when it has to answer, provide that guidance, and help us in connecting with new data. So while it's doing all of this, it is still going to give the guidance even when it's getting the new data. So all of this is conceptual. Ajit's demo, you'll really see the what I mean from this. So just remember this diagram in terms of guidance and context. Okay, so think of a Gen AI model. This is a brain. Okay, it's connecting to a data source like a database, and it has the context, or it has some special guidance that can, you know, um, help us improve the output. Similarly, for any kind of API or any kind of applications. So to give a sneak peek here, imagine if you could chat with your database directly. That is possible. That is going to be one of the demos today. So chatting with your database. So you don't know what is if some of them don't know how to write a query, you can just directly go chat with the database and it'll do the query for you. It'll come back and it'll tell you what it is. If you want to analyze certain things and say, hey, you know what, how many sales are there? What is the projected value? It can go and run queries in different places, come back and tell you, okay, this is the projected value. We are missing so much. We can do ABCD in this regions to do it. So something like that is at a very high level is possible here. Okay. So let's talk about the architecture now. We spoke about MCP. So we spoke about LangChain. We spoke about workflow automation. So what is this model context protocol? How does it work? What is the architecture of it? So you have this LLM, which is the brain. Okay. And it's going to connect to a client. So what is the client here? This is the Cloud Desktop. As of now, MCP is available in Cloud Desktop only, but you can find a couple of hacks where you can use it with different platforms like Olama or any other thing. So you can use it with Visual Studio Code or your Mac terminal. Okay. So here we have MCP servers. So what are these MCP servers? These are a specialized server which is built by Claude. The configuration and all the details that'll come up in the demo. So this is the AI that will provide the context to whatever data or applications we are connecting, and all these are secured. So because why is it secure? Because while we are connecting to the MCP server, it's again a little bit of code, and we can add all the RBAC or role-based access controls here. Okay, so you can see two of them green in color. So imagine these MCP servers are connecting to these data sources, which is, maybe a SQL DB, a NoSQL DB, a Graph DB, a Vector DB, Postgres, okay? Plus, it's also connecting to some kind of API. So I cannot have a database access of a stock market, but I can have the API access where I can pull information from the API and then, ask my, model context protocol server to securely put this to me, okay? So next question would be, how do we get started with this MCP? Okay, so first you need to install Cloud Desktop or any other IDE for this matter. As it goes, where many things would be supported, this model context protocol would work for others. Then connect to the required Gen AI model. So within Cloud Desktop, we have Sonnet 3, Sonnet 3.5, or any other model that is available. So we need to connect to that particular model. Then install an SDK. So for this model context protocol, we have SDKs in Python, TypeScript, and also Kotlin for a matter. I'm sure any Kotlin developers here? I guessed it. Okay, that's why I didn't include Kotlin. So yeah, mostly you can use Python and TypeScript, install the modules, and you can customize this MCP how it comes. So as we go to the demo, we'll understand, but at a high level, please keep these steps in mind. Okay. Then we need to update the IDE. In this case, the Cloud Desktop, we need to update this with certain kind of settings. For example, most of you might have used Visual Studio Code. When you install an extension, you have the ability to configure it, to enable it, to disable it, etc., using JSON or some kind of UI. So a similar process needs to be done. So once you finish all of this, I don't know it's going to work or not. Okay. So what we can do at this point is to make things more easier. Instead of installing the module and configuring it and customizing it, Docker has a container that can do this for you very quickly. Okay. And this is available in hub.docker.com/MCP. So certain standard functionalities of what the MCP can perform is available in this. And, keep this in mind. This is a high level process. Once it comes to the demo, you will really understand this part of it. Okay. So Next question is, what are the tools I can use? Hey, you told me MCP is interesting. MCP can do all the stuff, but it's all very vague. What can I do actually with it? Okay. So these are the standard out of the box things that you can do. You can, play around with data or any kind of file systems. You can say, find me this file and the contents inside it and give me a summary of it. Or you can go with certain development tools, make it do stuff in Visual Studio Code or any other IDE, any kind of web browser automation like our Selenium does, right? You scrap the web page, you go and click on particular things, testing, etc. Okay. Then comes productivity and communication. Okay. So we can use it in tools like Asana, where you can list all the boards and other things inside it. Okay. So you can see the list of available MCP tools in this. It has quite a lot of tools. Of course, you can come back and see even the Docker MCP hub. So we can install the MCP server using this command pip install MCP and then slowly develop it. We can also use Node, where we can install this Node thing and then build our server and put that in the configuration. Okay. So this is going to be the feature set that I've taken it from the MCP website. So it is model context protocol.io. It's all one word. So you can use this. This is going to be the features that is there, and whatever clients and upcoming updates are all available here. So you can go through that. Whatever we've covered until now is only at a very high level. In our future meetups, definitely we aim to make it more insight in terms of additional technical details before we go into the demo. So over to you, Ajit. But just before we go, let's have an energy check. Come on, guys. Okay, I think this time these people won. Okay, over to Ajit.
Okay, hi everyone. I know that we have been talking a lot about the theory, and I will be just covering the demo. I will show you all the demo which you have gone through. And let me tell you something. This might be scary for DevOps and SRE engineers, for sure, what I'm going to show today. And there is always a way how you can go ahead and see how we can automate things. Definitely, this is one protocol. And I will tell you the story what happened. Like someone built this protocol, I went and shared it, and then there are a lot of things happen internally to Docker also because people are building it. And I am closely monitoring this MCP, but I will show you a demo and then you decide, okay? Okay, fine. Who can help me in running a Postgres container here? I want to run a Postgres container running on port 5433 with password dev. What is the quickest way? Docker desktop. I am in Docker desktop. Let me go here. Okay, how many of you have tried Ask Gordon? No? So let's ask AI, right? What do? The first thing you do is ask ChatGPT. So I will go to this one and let me show here. I will open a new conversation here. Okay, let me type it, okay? So I'm asking just like a ChatGPT. I'm asking, okay, deploy, okay, help me in deploying Postgres container with password dev and running on port 5433. So Ask Gordon is basically your AI assistant. Okay, rather than you going to the chat GPT and asking, I am asking the Ask Gordon, which we have already integrated, but not yet integrated with MCP. You will see it very soon. So rather than asking even the chat GPT, I got the answer. It is Docker run. And did you notice this? The standard port of Postgres is 5432. And as I said, 5433. Okay, it gave me the answer. And then I specify that I need the password to be dev. So it says, okay, Postgres password. This is a configuration with just one single command. And the rest of the things you can just go ahead and ignore. We'll keep it as user, but fs sync, we'll keep it because it is more from the production side of it. We are in the development machine, right? So once I click on run, what will happen? Okay. This is very similar way how you go to the chat GPT and do it, right? So what I'm going to do here, I will just pick up this command. And I don't know how many of you really know about this. We have a terminal integrated right here. I don't even really have to open PuTTY or go to the VS Code. I will just say run, and it will deploy a Postgres server for me with password dev running on port 5433. Yes? But one thing you might have noticed that the Ask Gordon doesn't know about my Postgres database server which is running. It doesn't know. It doesn't have any context. If I run it second time, what will happen? What will happen? Huh? No, it will fail. The reason being my port 5433 has already been occupied, right? Now think of it is, if AI can understand my context, if it can know what is running on my cluster, forget about security at this point of time. I know you will always ask, why should I give ChatGPT access to my data center, right? That is what I'm talking about. Okay. So we ran this. Now let's do one thing. And how many of you know about the Postgres commands? If I want to enter into this container, the first thing is let's verify if this container is running or not. Okay. So I will say post. And I can see that there is a Postgres container which is up and running, right? If I want to enter into this container, what is the quickest way? Wow. You go to the exec command. What next? P. What is the username? Okay. I'm not doing anything. You guys are helping me. Okay. Okay. What next? How can I see the schema? How can I see database? Okay. /c Postgres. I am connected to my database called Postgres and user as Postgres. Okay. What is the command to see the schema? I can see the schema, right? Now this looks good. So I have a Postgres running. So let's add some kind of a tables, right? So I will do one thing. I will just open my demo. And what I can do, I have created some dummy tables, which is users, order, and product. I'm just starting with a very basic, and then we'll go to the high level. So what I'm going to do here, I paste it here. I will go back and query my list of tables. Copy this. And you can see here, I have few tables added to my database. It's good? Okay. Now, what do you think if I give my chat GPT access to this database? Is it possible? Is it possible? Has anyone tried it? Giving your chat GPT or Gemini access to your real hardware or data center, which is in your servers, which is sitting inside the data center, right? So let's try this. I have an MCP already set up. We call it as an MCP server. So the server name is Postgres MCP server. Okay. Now let's do this. I'm going back here and I will jump into the slides. And let's do this one. Okay. The first thing you need to do is I installed Docker Desktop. I have a local setup. Just like Postgres, I have a Neo4j extension, which I built long back. I have a Kubernetes cluster. And let me tell you, starting yesterday, we have a support of multi-node Kubernetes cluster. So I can set up 8-node cluster right on my Mac machine. Right now I have only 4-node cluster, but if you update to the latest version, you can set up a multi-node cluster, which means that you don't even have to learn all those commands, kubeadm and all of these things, right? You don't really have to worry. Just one click, your 8-node Kubernetes cluster will be up. So right now what we are going to do, we have a Postgres. I have a Neo4j. With Docker extension, I can set up Neo4j with just one click. I don't really have to even run Docker Run or Docker Compose today. I will set up an MCP server, and MCP server is just one simple configuration file. That's it. Okay. And I have a cloud desktop. So let me show you this. So what I'm going to do now, as you know, this is how it look like. Everyone can download Docker desktop. You set up an MCP server here. Now, this is a simple configuration file, what I need. That's it. You don't really have to install anything. Right now, if you see, there are two MCP servers. One is Postgres, the other one is Neo4j. Now, these MCP servers are containerized, which means that even if it is right now, your MCP server can be built with Python or Node.js, but what we have done, we have containerized it. So you just need a Docker run command, specify MCP Postgres and image, and I am passing here an entry. Now, did you see there is one entry which I need to modify? What is that? Port, Postgres, right? So right now the Postgres is running on 5432. I just have to go ahead and modify it to 5433. Rest of the things, again, for the demo purpose. If I want to use Neo4j, what do I need? Now, Neo4j here is not being containerized. It is purely a Node.js, but you can do it. So that is the whole fun, right? If you do nps command, which means that you have to go ahead and deploy it. But with Docker, you just need to run Docker run command. And here I'm specifying the Neo4j URI, username, and password. So I'm going to set up an MCP server. And how I'm going to do that? So I have a Cloud which is running on my system. Okay. If I go to the settings here, go to the developer. Right now, if you see what I have done here, there is a configuration file which I can open in any of the text edit or any of the VS Code. So this is an entry. Now, if you see this, what I have done, there are two databases and one Kubernetes cluster, which I have specified here. Okay, I don't know whether it is visible or not, but let me show you. Okay, the Postgres Neo4j in Kubernetes, just hardly 2 lines. npx MCP server Kubernetes, that's it. This is what I need to connect to my local database server as well as the Kubernetes cluster. Now, imagine if I go to the ChatGPT and say, deploy 3 instance of Nginx with this and this configuration right to my Kubernetes cluster, and you won't believe it will do it, okay? Even there are Figma pages. Today, if I want to create Figma, how many of you use Figma here? Have you heard about Figma? Imagine saying, create 3 Figma pages for me for my website, and it will just go ahead and create those pages. How? Like, it is not like you are asking ChatGPT and random answer you are getting, even the DeepSeek, right? Everyone is talking about that. You use that, but it doesn't know the context. Here, I know the context of it, okay? So what we do, once you add this configuration, I can go to the cloud, open a new chat window, and now I start chatting with my Postgres SQL. Okay, what should be in the Postgres, you saw there are 3 tables, right? Who can help me with the query here? What shall I ask? And right now, for security reasons, I'm saying like I can only do the readme, okay? So let me go ahead and start here. And I'm saying, show me the list of tables in my Postgres database. I'm chatting with, say, ChatGPT. It will ask you for the permission, okay? This is where your security come into the picture. I will say allow. Once I allow this, your chat GPT or AI assistant can access your database, which is sitting on your laptop. Now, what do you think? Do we really require DevOps for this or SRE? This was something, and you know what? This is an open source framework. This is an open source framework, which means that there is a function. And how do this know, like, if I can list or not? So if you see there is an hammer sign here, I click on it. These are the functions. Can you see this one? List pods in my Kubernetes cluster, lists all the namespace. Even I can run the pods, right? Did you see one thing? When I say list, I am not running. I don't even know what Postgres is. I'm just typing it in very natural language. Now imagine if I say, okay, create 3-node Nginx instance on my Kubernetes cluster, on 8-node Kubernetes cluster, ensuring that all the nodes should run in Nginx instance. Now, what is the first thing you will do? Go to ChatGPT and ask for, okay, can you help me with the YAML file, please? I don't really need that, because now with a simple natural language, like simple query, I can do that. Okay. Now let's do one thing. We have talked about because right now, if you look at the Postgres, right? In Postgres, there is only one function which says I can do a read-only SQL query. Now, this is one way of the security which you can impose. You can have an RBAC configured here. You can have some kind of access to it. Now, this is a read-only, which means that any user can go ahead and only read only. I can just list it out, but I can't go ahead and create those databases. Once I do create, it will show me an error message. Say, if I want to add a new, let's see, okay, add a new table to my Postgres database. Let's see what it does. Apologize. Because that function is not defined, right? Which means that as an open source, you can always go ahead and add those functions to it, right? Now let's move from Postgres to Neo4j. How many of you are using Neo4j here? Anyone? Yes? Do you remember the commands, the query? Yes? Okay. I have been using Neo4j, but still I don't remember those commands. Okay, so what I'm going to do, how many of you have used extensions here? No? So, okay, one hand. So if I want to run a Neo4j, what I can do, I can install an extension, which means that I don't really have to even run Docker run or Docker compose. So right now, this is a Neo4j extension, which I built last year. Okay. And already you can see here, we have around close to 3.6K downloads. The whole idea is I just have to go to the browse, search for Neo4j, and Neo4j appears. If I want to deploy OpenShift, I click on OpenShift and it gets deployed, which means that I don't really have to even go to the manual, okay? But that is, again, a separate topic. So I have a Neo4j, which is an extension, which looks good. And then what I have done, say I have a movie database, okay? Now, how do I input all those, actors and movies and all of this thing, the data set? It's basically, you can go to these sample scripts, go to the examples and movie graph, and you can see here, you can just execute the query. Now, if you see here, every time you use the Neo4j, right? If I want to execute this query, I need to literally understand how the query would look like. Say, if I want to, Neo4j has some kind of a cipher queries, right? I need to understand it. Now, how wonderful it would be if I just type something like a chat GPT and try to query all those movies, right? So let's do it. So what I have done, we can specify the multiple MCP servers on the same config file. You have seen we have specified Neo4j, right? So what I'm going to do, I'm going to go back to my Cloud database, open a new chat here, and start saying, okay, list all the movies acted by Keanu Reeves. I don't know how many of you have watched Speed movie back in 1990s. A lot of people, right? So right now, if you see, I'm not running Neo4j Cypher query here. I'm just typing it like a chat GPT. And it has access to my existing database, Neo4j database. Okay. How many of, yeah, any question? Okay. Now let's do this. Okay, this is an interesting stuff which we were trying with Ravindran. Okay, can you please change all the movies of Keanu Reeves with a new director? Say, how many of you are fan of Salman Khan here? Let's do that. Even though he is an actor, but let's try this. So I'm running a simple query. And what it does, it basically goes ahead. I will help you reimagine the movies with Salman Khan as a director while Keanu Reeves as a lead actor and all this thing. So what it is trying to do here, okay? And it will, okay, let me do something here. Change. What is the query? Just help me with the query, man. Add a director as add Ajit Raina as director for all Keanu Reeves movies. Let's try this. Hang on. So what I'm going to do, not to confuse, I'm specifying because we have further databases to it, right? So it says, okay, go ahead and I will create a nodes and relationship in Neo4j to represent all this with Ajit Raina as a director, okay? Now what is trying to do, I'm trying to access it. I'm making the changes right into the database. Now it went to the, everyone knows about the metrics, right? So it went ahead. It is trying to, specify, because in Neo4j we have nodes and the relationship, like there are two different parameters. Now, before it make any changes, what it does, it basically asks me, okay? So right now, if you see, my name has been added in all the directors. So think of it is like I am making some changes. I'm giving the permission to make those changes, right? And what it is doing, the MCP server is intelligent enough to make those changes. Okay, how many of you use, this is the last, like I will take 2 minutes. How many of you use Kubernetes here? Almost everyone? Okay, so let's do this. So I have, let me show you. So I have a 3-node Kubernetes cluster running on my Docker desktop. As you know, we supported a multi-node cluster in Kubernetes. I will go back to the cloud. I will start a new chat here and say, deploy Nginx instance on all the Kubernetes nodes. I haven't specified any YAML file. I'm just saying, just go ahead and deploy in all the nodes. So 3-node cluster. And I'm expecting that all the 3 nodes should have an Nginx running. So no YAML here, just, okay, what it says. Let me try a different approach by creating, okay, let it try. Now we have become habitual of DeepSeek, right? Thinking and everything. Okay, you have seen here, I have successfully created one Nginx pod. However, I noticed that available function doesn't support creating a daemon sets. Okay. Now the reason why it says that, because the functions which I have, so few of the functions like, okay, creating a namespace has not been created, right? That has not been written. But list of the things like delete a Kubernetes pod, execute a list deployment, list all namespaces. Say if I am trying this, list all namespaces. So it's more like I'm sitting on ChatGPT and asking about specifying all the namespaces. So you can see all the namespaces here. Okay. As you have seen, what we do here is the MCP server which you are building, it might be in especially on Node.js or Python. But one of the things what we have seen here is you can use Docker in almost all the phases. Like you can use Docker desktop to containerize those and host it on MCP servers, right? Especially on the Docker Hub. So the whole idea is whatever I showcase now, it's very recent development which is happening. We have close to around 400 plus MCP servers, Figma, Snowflake. You can talk about nodes. You can talk about any of those servers. This is being built, which means that through AI, now I can access the underlying servers and make those changes, right? And that's why I said, right, DevOps, SRE engineers, you spend and we spend more time in writing those YAML files, maintaining it. Now think of it as like you build those functions and these functions automate those tasks. So it's a purely, you can understand that AI is in one way not replacing, it is making our task more and more easy. But who is going to build those functions? It's developers, right? Developers are going to build it. DevOps is going to test it. So what I said, we are not replacing it, but we are saving a lot of our time. We are automating things with the MCP. So I would recommend that you go ahead and try out this stuff, and you can run a multiple servers. And these are the references. I wrote a blog on how you can use it with the Postgres. I will be writing on Neo4j. With this, I think we are towards the end of the session. Any question? We can have 1 or 2 minutes. Yeah.
My question is more of a naive, I think. Suppose I am running on a local development and React is running on port 3000, say a Django-based ORM, like a application is running on port 8000. So I can pass those, like say local config to the config window of that, say cloud.
Yes. So say for Postgres, you will have a separate Postgres MCP
say
server.
PG admin or something like
Yes.
5432.
Correct.
And both like React on a several port and that Django on a several port. So
So for each of these services, you will have a separate MCP server at this point of time, because MCP server just came in month of December. Okay. Now, if you talk about one specific database, Django, I need to have a Django MCP server. Yeah, no, if you have to write it as a developer, it might be available. So if you ask me the Figma MCP or say Django, I don't know whether it exists or not. I need to look into the awesome list. So there is around 400, 450. So today you have millions of software, right? So for Django, you need to have a Django MCP server. For Node.js, we have Node.js MCP server, right? Even though Node.js is built, say nodes, say MS SQL server, we have a separate MCP server. So you have to specify everything in that particular configuration file. No, it doesn't work like that. Local IP or something. You need to have servers. These are MCP servers, which runs as a container. So if you see in this example, I have an Postgres MCP server, which is running. That's why I am able to communicate with Postgres. It's not like you specify the port and you get connected. That comes when you implement a remote MCP server, which is still in development, I would say. Say, I am sitting on my laptop and my Postgres is running on my Azure. That is, we call it as a remote server. Either you pass the access key and give the access to it. But for each of these MCP servers, you need to have for this MCP service, you need to have a server running on your local machine. Say if I have a GitHub repo, and if I want to connect to that, we call it as a remote MCP server, which you need to run it. But the packaging happens as a Docker container. Any further question? Yeah.
One request. Start with the snacks with few, because there are many people cannot go at once, and we'll keep running with the questions, and we have 2 more talks after that.
Yep.
So in the list, we saw a specific list, right? Like for example, read only access or list namespaces. So those are the functions that we need to write that when we build MCP server?
Correct.
Okay.
So these are the functions which are rightly, if you go to the Postgres MCP server, you will see there is a function defined. As I said, right, you have to build it from scratch. So right now, the function which is defined is read only.
Okay.
Otherwise, if you want to allow user to create it, then you have to create function.
Okay.
Yeah.
So the basic MCP Docker container, you take the Docker container and build on top, build functions on your own and deploy the MCP server.
So usually if you go to the Postgres MCP server, in a GitHub repo itself, you will see a file where all those functions are specified.
Okay.
Okay. Now, once you have specified, then you build a container. You containerize it.
So it's basically is similar like how you create any of the microservice.
Correct.
Right. So you create your, say for example, REST API server, you have your endpoints created, you are deploying it and plus you are hitting it.
Correct.
So instead of deploying your your REST application, you are creating MCP server.
Correct. Think of it like a microservices, as you said. Yeah.
Okay.
Yeah.
Hey everyone, good evening. Can you all hear me? Backside, is it audible? Yeah. So sorry we called you very early from the snack break, but we wanted to start this session. So yeah, today we are talking about integration testing with test containers. I'm very happy to see people around who are very interested to know about this. So before getting started, let me introduce ourselves. So my name is Shubham Raj, and I am a software engineer too at Cloudera. I work with Cloudera data engineering team, which specifically deals with the private cloud. I'm also Apache Airflow contributor. I've also spoken at Airflow Summit 2024 and 2025. Apart from this, I'm also a published book author. I also have Tarun.
Yeah, hi, I'm Tarun, and I've been with Cloudera for last 7 years, and mostly I've been working on Apache Yarn, contributing to it, maintaining it, and focusing on auto-scaling it in cloud. And I think last few years, I've been working on the Cloudera data engineering platform. Yeah.
So yeah, let's get started. So what is test container? Before getting started, I want to ask everyone like here, you might be having some instances where when you found a bug by the end user or in the production, and you always might have a thought about like, oh, what could we have done right so that we could not face this issue? What testing could be done right? So what test container is, it lies very at a sweet spot between the E2E testing and the unit testing. It have a very sweet spot of integration testing. So test containers is nothing but is a library for integration testing. It provides you real disposable instances for dependencies, ensures production like replicas to your local environment also, and automates setups and tear down of your services so that you do not need to take care of any of the resource leakage. And so ideal for microservices and distributed systems, good for the cloud native apps you build. You can do the integration testing with the help of this. So this photo is very apt for this. Why do we need it? So you might have heard this particular statement from many of the developers talking with themselves. Okay, it worked on my machine. It was not working there. But in the real world scenario, this doesn't work. You cannot expect the end user with a statement like this. So you need to minimize the bugs and minimize and you have a good replica of an environment to a local. So you do not have this problem of, okay, it worked on my machine, but it's not working in the CI builds and all. So I will tell you one real world problem, what we face is, like, I will give you an example of how in which scenario this test containers will come up. So imagine this, you're working on a microservice based application. One service depends upon Postgres, Redis, and then Kafka. There are multiple services. And integration test works locally, but it failed randomly in the CI builds, or it might fail something with weird reasons in the CI build. So what could happen, right? So database setup might be incomplete. Your local might have a different versions or something, different Kafka versions from the production, or there could be many failures, or there could be many reasons accordingly. And the worst part is the results will be like flaky, unreliable tests. Debugging consumes hours of effort. Being a developer, I know the pain of that. You are debugging for last 2 hours, and eventually you are bottlenecked to the point that it was just a version mismatch, and that's it. So, and of course, it works on my machine, problem persists, right? So I will give you some benefits of the test containers. So it's a lightweight and easy real services. No manual setup is needed. You just have APIs for all the languages, and you just call it and just have an ease of bringing up the containers from it. TL services, it just makes a replica of the production level dependencies. Isolated, you have a reliable, clean test environment so that you do not have any problem or you do not have any test interrelated or creating a problem for each other. Docker powered, portable, and it's a scalable infrastructure. You can scale down or scale up as according to your need. And advanced feature, it have wait strategies. So it's very important to have the container initialized before any of the test is being started. And for networking, so you can have multiple test containers talking to each other in an isolated environment so that it also do not affect for other Microsoft integration testing going on. And the cleanup is like you do clean up all the resources, do not leave any dangling resources or containers going on. So there are some core concepts. I will go like container lifecycle. It's nothing but the lifecycle of a container. So it starts with setting up the container before the text gets executed. And once the text gets executed, you will have the cleanup of the container. The second is Docker images. Test containers pulls images of a service that you interact with. For example, Postgres or Redis or whatever services you have, just bring it up. The dynamic setup, it's containers can be created with the dynamic port bindings, environment variables. You have a lot of things to edit and you can choose dynamically. Test containers API, as I told, it's very simple, provide simple Go API to interact with containers directly with your test. So now I will ask Tarun to explain you how the test container workflow works.
Yeah, so test containers is a fairly simple abstraction and where it manages the lifecycle and takes care of setting up the test containers for you, right? All the dependencies, external things that are very much needed for integration tests. Now for the setup, it's just basically just configuring the container, right? Like how you do in a Docker file. You just need to do it in a programmatic way. And this is lazy. So while configuring it, it doesn't start the container immediately. Only if you send a container request, then it starts the container. And then the run test part, actually, this is fully controlled by your code. You write the integration tests, and that interfaces with the test containers that are brought up by the framework. And finally, cleanup, which is the main part. So test containers has a Reaper kind of container that takes care of cleaning up the dangling volume mounts and everything. I mean, how many times have we seen, with Docker desktop, like you have, multiple containers spinning up, running your tests, and then you see, a week later, your laptop is full, right? So this kind of prevents that, which is really important if you are, using a small CI instance to run your integration tests. For a very simple example that we did in project is basically just use it for two different databases, right? So we had to migrate from MySQL to Postgres, and to not break our integration tests, we just had to plug in the test containers separately for MySQL and Postgres, and that made the job easy, right? And this is a sample test container request, and as you can see, it's kind of similar to a Docker file where you define all the configurations and then start the container. So this is one example for MySQL. So what we also wanted to do was extend this to our own microservice that we had. So we have something called Spark History Server within Cloudera Data Engineering. And this has dependency on multiple things like Spark versions and also the data format. The problem is this, the data format within the Spark event logs, they keep on changing as you upgrade Spark versions. And since this is more of a history server that is interacted primarily by the customer, we wanted to ensure that upgrading Spark versions doesn't break it. And it's not easy to test it within our unit tests because even in Spark unit tests, it covers for only that specific version. But since CD manages multiple Spark versions, it's tough for us to ensure the compatibility is not broken. So for that, we had to simplify this lifecycle and try to mock the entire thing with test containers. So for this, we basically have kind of simulate the same thing. That is, have a fluent bit test container and yeah, and the fluent D, and then Ozone with multiple process. And the only thing that I exposed in Ozone is a S3 gateway. Ozone is a distributed object store that we use in Cloudera. And then Spark history server consumes the logs from this object store. So we have this complicated setup that requires multiple external services, and this is something you cannot easily mock, right, within your integration tests. And test containers, however, makes it much simpler. And also, you can bring this up within a minute. So let's go to the demo that showcases this. Yeah. Yeah, so I have a very simple test just for this demo where I am testing my Spark history server. So for first, I'm actually setting up all my test containers, Ozone, FluentD, FluentBit, SHS, and also ensuring they don't leak and they terminate gracefully. And if you see, it's just a simple test where I just query the Spark history server endpoint, and I'm able to get the container port. So test container, one main advantage is all of these ports are dynamic. So you can actually run this test parallelly and it won't really conflict. All these containers run independently of each other, even if you invoke it parallelly with multiple instances. So you can see the sample way that we have configured, like Ozone, we had to add all these services and bring it up. Similarly, we had to do it for the Spark history server. So it talks to the Ozone based on this configuration and uses the Ozone container port. And FluentBit, same thing, and then FluentD. So all of these use a dynamic configuration port, and they depend on each other. So they're set up one by one. So let's have a sample run of this. So yeah, as it's starting up, I guess let's see the test containers. Test containers also provides a UI where you can see what the test containers are, which test containers are brought up. Since I've run this multiple times, it's showing these. As you can see, each time it's bringing up these 4 containers and the timeline for them. Now let's go to the console. Yeah. So as you can see, it first brought up the Ozone distributed object store, and then the Fluent plugins, and then the Spark history server. And finally, tests were able to run. So yeah, finally, it just started history server. And as you can see, yeah, now it had added another instance. It's slowly updating here. Yeah, so finally, after bringing it all up, it was able to complete this entire setup within a minute. And this included bringing up the entire stack as a pipeline that just works seamlessly with the minimal code. So yeah, that's it from the demo part. So Shubham, over to you.
Thanks, Tarun, for this great demo. So we also support large supported languages. I think and everyone here might have used one or the two or some words from this supported languages. So test container are supported for this all, and they give the APIs for this all. And the community is very helpful. And for our project, we use dynamically Go with it. So there are some common best practices, and it's just like a salt, it shouldn't be less or more, it will just destroy your food. So something best practices should be followed in the same way. Leverage Defer for container cleanup. You always used to use Defer for so that your containers do not dangling around and there is a problem of a resource leakage. Use context properly in the terms of the Golang. We use the context there so that the test do not, create a dangling containers. Choose the right test life cycle. You should know when to start the containers, and the tear down of the container should be proper. Run containers in parallel so that there should be a speed in the test, and do not need to wait for something. Use specific container images for testing, or like, for example, use some light images such as alpine images to use it. The wait for containers to be ready is something like wait strategies, where you wait for the containers to be complete the setup so that you can run your tests. Post that, use named networks to isolate dependence. There could be like we showed one of the use case where there were multiple test containers which were using it. So use it in the named network so that there's not create a conflict for other microservices integration testing. So limit the number of containers in the test. Do not bring unnecessary multiple containers. This will just decrease the speed of your text execution. Handle timeout gracefully. Even though you are having a timeout, you should always keep a proper log so that you can know, okay, what could be the bottleneck. This will prevent you to have a wasting of your time when you face some issues. To avoid intermittent issues with Docker Hub rate limiting, you even in your real projects, you can might use your internal registry to host the images so that when you have a very bulk project or there are multiple calls to the Docker Hub, it do not get the rate limit, and it might create a flaky test or the problems of timeout. So yeah, that's all for the test containers. I hope you like the presentation. You can also connect with us on the particular handles. And if you have any questions.
So do you recommend using test containers for local development? Like if you're doing on your laptop, for example, is that a valid use case?
You mean for the local development?
Yeah,
So,
when as a developer, for example, do you still recommend that as a workflow?
yeah, I mean, why would you wait for the CI/CDs pipelines or something? Because for now, as a developer, you write the unit tests, right?
Right.
And it might be possible the unit tests are passing, but there is a lot of dependencies for something which you are building. So you might not know now, but after the CI builds are being done, then you will know, okay, this is a problem. That's what you can replicate the particular production level replica to your computer, right? Local system. And you can know that, okay, this might be a problem. Okay, I will fix it soon.
I'm asking because let's say, do the containers still run when you're, let's say, the full test run, right? So the containers are still running when between test runs, or are they completely shut down after
No,
each?
yeah, so they are completely shut down, and even the the volume references, they are cleaned up, right? So it has a specific Reaper pod called Reaper container called Ryuk that does that. So as you said, right, like for using your local laptop, so basically the main use case is you have a written and integration test, right? And you want it to run in your main CI every day within a short period of time, not run for hours like deploying an actual cluster, right?
Right.
So in our case, what we showcased Ozone, right? So deploying it in a CDH cluster takes hours, right? For the entire service. So instead here we can just do it in minutes and have it running, frequently within our CI. And the same thing, if you face any problem, you can run it in your laptop and it behaves the same.
Okay.
And you can do all this declaratively within your code. So there you can easily control whatever parameters you want to do.
Okay, I was asking because nowadays test test suits run on a file change, right? Like every time
Yeah.
you change a file, the whole test
Yeah.
suite runs in that case. I was curious whether it'll do that full tear down every time that you make a change, then the test suits will become very slow, right? So
yeah, it will do, but each of them is a separate instance. So if you see in our case, each of them map to a dynamic external port. None of them use the same port. So each time it runs, it uses a separate dynamic port. And once you launch the container, you can get the container request details to get the dynamic port details, and thereby you can link multiple containers, make them talk to each other more easily.
Thank you.
Any more questions?
Since you are bringing up the containers dynamically, right? In the code, how do you ensure that you are connecting to it? Because the port is also changing every time. So just curious about that.
You get the question? So what keeps changing? Like you mean the container version itself, or
The port, the DB port, for example, I think you said that it will keep coming up with different ports, so there'll be no port conflicts.
Yeah. So
Did I understand that?
the external port that is exposed outside the container is dynamic. The internal port within the container, that is a static one. So within your for example, in this the ozone, we have within the Docker container itself, the process will listen on 9872, but from outside the container, it will be mapped to a dynamic port, right? So, and this dynamic port is always random. So each time you run the test, that changes. So you can run the test parallelly, and even though within the two containers, both of them are listening to the same port, but outside the port that is mapped will be a dynamic one and different between them. So that way you can avoid conflicts.
So the way you integrate with the SDK, it automatically picks up the report for the container it's spinning up. We don't need to do anything about it.
Yeah, exactly. Yeah.
Yeah, my question was also on the similar lines about routing. And so what about, like, let's say we have n number of containers in a microservice environment. Like, will that scale in a local development setup? Like, how can like we can run that much containers in a laptop? Is it possible? And one more question is um, like, is it possible, like I can say, I don't want to run these number of test containers. I just want n minus 2. So maybe I'm working on 2 different repositories and I want to test against my local environment. So how that is done actually?
Yeah, so the setup is completely programmatic in this. So you can control what you do. But regarding the resources required when running in laptop, obviously, I think if you run a lot of big containers in your laptop, it will be slow. At least the test will be slow. So one thing is the integration tests. At least if you're running in local, you should try to reduce the resource allocated to it. Yeah.
Okay, have you heard about test container cloud? Anyone? No? So think of it as like, if I want to run a test container, sometimes it happens that it consumes a lot of your resources. With test container cloud, I can run the testing over to the cloud itself. You just have to pass a kind of a service API key. That's it. So your testing will be done over to the cloud. It will spin up the container. It will execute those unit or integration, especially we target integration testing, and then it will clean up the resources. So in that way, if you are busy with your laptop or say the development environment, and if you want to offload it to the cloud, you can use that. So we have both test container desktop app, which can fix the porting issue, port mapping, the dynamic port allocation. And then we have a test container cloud, which can offload your whole testing to the cloud itself. In that case, your local resource won't be used. Yeah, so this is the one where you can just specify, if you want to run over the cloud. So you can, I don't know whether if you have installed test container desktop app, you can see that there is a kind of, direct, you can connect to the test container cloud. You can use that. Just give it a try, and that might solve your problem.
Thank you. Thank you so much, Shubham and Tarun.
Yeah. Thank you so much, guys.
We'll move to our last talk. I request Ashoka and Girija to come and present, please. Thank you. Great applause. Yes, yes. And please don't leave after that. We'll have a group photograph. You guys are leaving.
Hello. Hi. Hi, everyone. Myself, Ashoka. I'm a staff engineer working in Cloudera from past 3 years. I have total 15 years of experience in the IT industry. Along with me, Girja is there, my colleague. She is working as a software developer. She has over 4 years of experience in IT industry. So today, let's talk on advanced Kubernetes securities. So the main contents I'm going to cover is like first we'll explain like what are all the different components in the Kubernetes and what are the vulnerable surfaces in the Kubernetes, and we'll discuss like how to secure different components of the control plane like API server, etcd, secret management, all those things, and also we'll discuss about RBAC. Okay, and also we'll discuss about the securing different components of the work node parts. Okay, like work node, like basically part security, image scanning, network policy, logging, etc. So before I explain the risk-prone areas in the Kubernetes, right? Suppose if you are using Kubernetes from the, or basically if you are using the managed clusters, right? Like AKS or EKS or GKE, right? Then you don't need to worry about the security. Most of the security part will be taken care by the cloud provider. So if you are running your own cluster, right, then we need to take these things actually. We need to take care of these things. So if you see this, right, this is like a typical Kubernetes cluster. We have like a control plane and a set of worker nodes will be there. In the control plane, we have like a API server. This is the main admission. This is the main entry point for the cluster. And the etcd, here we have like a secret data and config data will be there. We need to secure this basically. So when it comes to the worker node, right, like uh, we have like vulnerable applications. Like it is possible that user can get into the container and he can execute the remote shell and he can access the different components. Okay, so it is very much needed to secure this. And kubelets is the main thing which will manages the background, which will manages the container and the Docker daemon, everything. So accessing, I mean, we have to secure this also. And one more thing is that for the network node, like if suppose if someone gets in SSH into the node, and if he tries to access or ping the network node, they can really mess up the cluster. So we have to secure the node as well. So mainly we'll concentrate on these things today, but obviously we have to secure all the components here. But these are the main vulnerable surfaces. Yeah. So when a request comes, right, like suppose if you do like kubectl get parts or get namespaces, right, the request will eventually hit Kubernetes cluster. Okay, I mean it will hit API server actually, but before it hits the API server, right, there are like multiple phases it goes through. So to secure this API server, right, there are multiple things are there. Like one is like authentication. So here, like first we'll ask the client to identify, or we'll verify whether the client is a genuine client, is a authorized client or not. We'll verify that, and then authorization will be there. So where we'll ask like whether the client has whatever permission he has, right? Whether it is whatever specific task he is going to do, right? Whether it is allowed or not, we'll check that, and we'll check the verification validation. We'll check in the admission control. So for the authentication, right? There are multiple ways to authenticate. Okay, one is like uh, certificate authentication. So here, like any client. Any client which is having a valid certificate which is signed by the CA of the cluster will take it as like a valid client. And if suppose if a client wants to authorize by an external authorizer, right? Then suppose some single sign-on client like Okta, if the client wants to authorize from Okta, right? Then what we'll do is like the request will be redirected to the external authenticator. There, the actual verification will happen, and the ID will be returned. That ID will be presented to the API server. So this way, we'll achieve authentication, and afterwards, right? Once we identify who the client is, right? Then we'll move to the authorization. So here, basically, we have to identify whether whatever the permission the client has, right? Whether it is correct as per the role assigned. We have to check that. So how to do that? That is like RBAC. So RBAC is like we have basically we'll explain this more in the coming slides. So here we'll have like a set of roles assigned. I mean, set of permissions will be there in the roles, and we will have different users will be there, and we'll do binding actually. And we will. This is mainly used for the like fine-grained access control. And then the next is like once authorization and authentication is completed, right? Then the validation will happen. Validation in the admission control will do validation. So suppose if, for example, right, if I want to run images only from one specific registry, right? Then we can get this done by using this admission control validation. So here we have like two things. Okay, one is like a validation webhook and mutation webhook. In the validation webhook, right, it will just scans through all the YAML files, and it will make decision like whether to accept or deny the request. In mutation webhook, right, it will here basically in the mutation webhook, it will based on some logic or some annotation, right? It will identify whether we have to update the ML files, or whether we have to accept or deny. That decision will be taken. And this is basically the admission control is for the validation. Okay. Once after all these things, right, the request will go to the Cube API actually. Yeah. So now we have like different, there are two categories of users in Kubernetes. One is like service account. Service account is like non-human user account, which is managed entirely by Kubernetes. Okay. Either we can create service account by using the APIs, or we can, when we create the namespaces, service accounts will get created. So basically, like parts are the entities, right? Basically, application parts are the different internal components, are the entities, right? Which wants to access the Kubernetes API, right? They will use these credentials of the service account to authenticate API server. And other than that, there is like normal user. There is no such construct in the Kubernetes which will identify the user. I mean, there is no such construct for the users in the Kubernetes. So any user who is having a proper valid certificate which is signed by a CA of the cluster will take it as like authorized user. So here you can see, right, like but now, right, once we identify the user, we have to identify we have to make sure that they have proper permissions. Okay, so how we can do that? So one is like we can define the set of permissions in the role object. Like we have something called as role binding, cluster role, and cluster role binding. So this role and role binding are like namespace based, and the cluster and cluster role are like cluster scoped. Okay, so in the role we are we are assigning like you can see here in the role, right? We are giving like a different permissions like under different resources for the pod, right? Like a user can do get pods, watch pods, list pods. These things he can do. Here we are not specifying the user. Okay, it is not bind to any user. This is like a role, and we will associate one user. I mean, we'll bind one user with this role. Like if you see this right here, we have like a role binding where we have like there's a user called Jane and he is binding to this role. So now Jane is allowed to access the pods like get pods he can do, watch pods he can do, list pods he can do, all those things he can do. Similar stuff is applicable for the cluster role and cluster role binding, but here is that this cluster role and cluster binding is applicable for the entire cluster, but the role and role binding is applicable for the only for the namespace. So this is one example actually. Here we have like namespaces, like foo namespace is there and some namespace 1, 2, 3 is there. We have like three users are there, like John is there, Jane, admin users are there. So there is roles also. One is like read secret role is there. Other one is like the read write secret cluster role is there. So here, right, John is associated with uh, read secret role and he has a role binding with that role, so he will be able to read secrets data from the foo namespace. There is one more user Jane. He has like a cluster role. He can read and write secrets actually, but the role binding is he doesn't have cluster role binding, he has only like role binding. So then that's the reason he is able to read and write the secrets from only from the foo namespace. If you consider admin, right? Admin has access. Admin has like a read write secret cluster role he is having, and he has a role cluster role admin cluster role binding also. So he is able to write and read the secrets from all the namespaces, like namespace 1, 2, 3, and also from the foo namespace. So, so this is all about like securing the uh, Kube API servers. Now let's move to etcd. So etcd is like a highly reliable distributed key value store where we store like a config data and secret data, those kind of things. So here the risk is that in the etcd, right, the data which is stored in the etcd is like a plain text format. So anyone gets into the etcd, right, like he can be able to see the data in that. So how to secure this then? So one option is like we have to encrypt the data and save it, one thing. And whenever we access the data, right, we have to give proper RBAC for accessing that etcd also. That is one thing. And also we have to enable like encrypt. We have to enable encrypt. Basically, we have to enable like TLS encryption for that to access this etcd data. So the next is like secrets. Here, so like the sensitive data like password, API keys, right? We can use secrets to store that. So even this data is stored in the etcd only. So again, if the data which is stored in the etcd, that is the secret data, right? That is like it will be it will like encoded. Okay, it will be encoded with base 64 format by default. So anybody like who hacks into the etcd, right, he can always decode it and he can see the contents of that. So how we can avoid that? One is like we have to store the data in the encrypted format. That is one thing. And the other option is like we have to use RBAC to control access to this. Okay, and we have to one more thing is that there are like a lot of secrets management tools are available, like HashiCorp, so Vault is there, or AWS Secret Manager is there. There are many are there. We can leverage that to store these things. And other than that is we have to avoid storing these secret data in the code. Like we should not hard code this code in the either in the code or in the configuration. We should not hard code this. So this is all about securing the components in the control plane. Now Girija will continue on securing the components in the worker node.
So, hi everyone. So, as Ashoka has explained the control plane security, I will explain worker node security. So, all of us know that Kubernetes worker nodes are the backbone of the cluster, which runs pods and workloads. By compromising a worker node security, which can lead data leaks and service disruption, so, hi everyone. So, as Ashoka has covered the control plane security aspects, I will cover worker node security. So, as all of us know that the Kubernetes worker nodes are the backbone of the cluster, which runs pods and workloads. So, if we compromise the worker node security, it can lead to unauthorized access, data leaks, and service disruptions. So our goal today is to harden the worker nodes and minimize the attack surface. So for that, there are four key security concepts. So we will go through them one by one. So first is pod security and hardening. Second one is image scanning. Third one is applying network policies. And fourth one is logging and monitoring. So let's dive in. So let's start with the pod and container security. So in this example, I have taken a pod which doesn't have any security configuration. So if we create the pod and exit into it, we can see that the process is running with the root user having UID and GID as 0. And if we check the volume permissions, so a user can access all the data inside the pod, which can, so this pod, from the functionality point of view, this pod can work. But from the security configuration point of view, it might include potential data leaks, as if the attacker breaks out of this pod, it can gain the control of the host, resulting damage in our Kubernetes cluster. So to mitigate this risk, we should follow some of the best container security practices. So first one is to use the container as non-privileged. So for running the containers as non-privileged, we should use the security context. So what do you mean by security context? So security context sets the privilege access controls for your pods. So some of the best security context options include running the user as non-root. So we can set the security context flag run as non-root to true to avoid running the containers as a root. So second option is disabling privilege escalation. So we can have the flag as allow privilege escalation is equal to flag is equal to false to avoid unnecessary privilege escalation. Also, we can restrict the file system access by using read-only file system is equal to true. By using this flag, we will be user will be able to only read the file system. Also, we can drop unnecessary Redux capabilities by using the capabilities is equal to drop flag. So these were some of the popular security context settings that we should include inside our pod. Also, we can set resources.request and resources.limits inside our pod to prevent resource exhaustion in case of DDoS attacks. So we can always limit our CPU and memory usage by using resources request and limits flag. So, and one more bonus tip is to use rootless containers with tools like Podman for extra security. So Podman is an open source tool which can build the containers with extra security, and which in turn they will run as a non-root user. So we can always use Podman for building and deploying our containers. So these were some of the best container security practices which every organization should follow. So next topic is image scanning. So why do we need image scanning? So if we use unscanned images, so they bring hidden vulnerabilities into production. So if we deploy unscanned images into the production, fixing them can cause downtime. Also, malicious images could introduce backdoors. So as all of us know that images have certain layers, and on each layer vulnerabilities can be found. So we need to scan all the image layers to for avoiding any security breaches. So some of the best practices for image scanning include using trusted image registries like Docker Hub or Amazon ECR or Google GCR. Also, we can scan the images before deployment using the tools like Trivi, which is a fast and lightweight scanner. Also, we can use Cloudera for static analysis for vulnerabilities. Also, we can use Anchor, which is policy-based security enforcement. So, and also we can integrate all these tools in our CI/CD pipelines for better image scanning. And we should always use the latest base images and the security patches whenever possible. So every organization's goal should be to use the clean, safe, and ready for production images. So here in this example, I have taken Amazon ECR. So if we push any image to the Amazon ECR, it does the vulnerability scanning for us. So in this image, you can see that there are several vulnerabilities, and we can address them one by one. But ECR provides us facility to scan the vulnerable images whenever possible. So we can use the cloud provider tools also to scan our images. So this was regarding image scanning. So let's move to the network policies. So why do we need network policies? By default, Kubernetes allows unrestricted pod-to-pod communication. That means one compromised pod can attack others, which will lead to sensitive services would be exposed. So for avoiding this issue, we should use the network policies. So you can think of network policies as the Kubernetes firewalls. So how do network policies work? I will explain them by using the diagram. So this is an example namespace which contains 3 pods: web server, Python backend, and database. So we will design a network policy for the web server pod, which will allow all the policy to the web server. So users can access the web server pod, and web server pod can access the Python backend pod, and Python backend pod can access the database. But web server pod can't access the database because of a network policy. So why we have done that? So if web server pod gets compromised, so our database pod will be protected, as our database contains security, our confidential information. So even if the web server pod gets compromised, it shouldn't reach to the database pod. So that's where network policies come into the picture to avoid any pod-to-pod traffic. So this is the working of network policies. So here I have taken the network policies YAML. So key components in network policies YAML is the pod selector. So by using the pod selector, we can define which pods are affected by using the network policy. So here in the match labels, we can see that the role is the DB. So the pod which has the role as DB will be selected by this network policy. Also, we have a namespace selector. So similarly, whichever namespace which has the label as project is equal to my project will be selected by this network policy. Also, we can define the ingress and egress rules to restrict the incoming and outgoing traffic. So by using all the fields, we can define the network policy. So some of the best practices for the network policies include we can start with the deny all policy and then slowly allow necessary communication. Also, we can follow the least privilege principle to allow only the required connection. Also, we can use the monitoring tools like Cilium and Calcio to help visualize the network traffic. So this was regarding the network policy. So our next topic will be logging and monitoring. So why do we need logging and monitoring? So logging and monitoring provides visibility into what is happening in the cluster, which helps in detecting anomalies and debugging the security issues. So some of the key components in logging and monitoring include audit logs, which enable Kubernetes API server audit logging. Also, it can capture and analyze audit logs using the tools like ELK stack or Fluentd. Also, we can use the container logs to monitor pods using the tools like Prometheus and Grafana. Also, we can use Fluentd, Logstash, and kubectl logs for getting the container logs. Also, we can include some of the runtime security tools like Falco, which detects the runtime anomalies and suspicious behavior. Also, we can use the SysDig, which offers runtime detection and forensics. So let's take a look at one of the runtime security tool, that is Falco. So Falco is an open source runtime security tool that monitors system calls and alerts on suspicious activity. So we can define certain set of rules inside Falco. So the rules can be detecting a shell inside the container, or a sensitive file like some sensitive file is read, or a curl or wget command is used, or a new package is installed inside the pod. So if certain events happen, Falco can give us the specific alerts. But remember that Falco can only send alerts. It can't prevent the attacks. So for preventing the attacks, we should continuously monitor these tools. And if any attack happens, it is our responsibility to take any action. So in this example scenario, imagine an example scenario where an unauthorized traffic between the pods is detected. So by using the runtime tools like Falco, you can see that the container spawned an unexpected shell. And by using the SysDig, we can further investigate that attacker exploited a misconfigured secret. So let's take a look at how we can install Falco. So Falco can be installed by using simple commands. Also, we can run the Falco inside our Kubernetes cluster by using Helm. So Falco can also be used as a container. So, and we can define an example rule. So in this example rule, we are detecting if the container shell is spawned. So if the shell is spawned inside the container, we will get the warning alert. So how this rule will work inside Falco. So if we start the Falco and if anyone has spawned the shell inside the container, it will give us the proper warning. So Falco can be used for detecting any vulnerabilities inside our Kubernetes cluster. And also we can use SysDig for further investigation. So SysDig also can be installed by using simple commands. And also if we want to get the detailed process information, like here I am getting the process information for cat, and I am adding the container ID. So it will give me detailed information for which file this cat was performed. So from the output, I can get that the attacker tried to access the etc/password file, which shouldn't have done. So this by using the runtime security tools like Falco and SysDig, we can monitor our Kubernetes cluster for any runtime vulnerabilities. So this was about all the security aspects for the Kubernetes cluster. And one thing to note that the security is not optional. So every organization should take care of the security for protecting your applications, your data, and your business. Also, by implementing these best practices, you can drastically reduce the attack surface for your Kubernetes cluster. Also, Kubernetes has one page that you can visit for checking the Kubernetes vulnerabilities. So it gets constantly updated for any existing Kubernetes CVE vulnerabilities. So that was about the Kubernetes security. So if you have any questions, we can discuss.
Girija, I think there's a question on Zoom. You can check that
Okay.
in the chat. Yeah. There it is.
The sysdig command is installed on the cluster node. So, so I think by default it is not installed. We need to install it manually, and we can do that by using simple commands. And I think we can run it as a pod also. So I hope I answered your question.
Do you have any questions offline? None.
Fine. If you don't have any question, thank you so much. Thank you, Ashok. Thanks, Girija, for presenting a nice talk.
Thank you.